briefly summarize in English a little bit too? Yes,
okay.
yes,
okay.
yes.
Okay, okay.
What we're going to do.
Okay. Sorry, I was speaking in Khmer, and my colleagues or other colleagues who are on Zooms and non-Khmer speaker, they cannot understand. Maybe I make a quick summary. So for today, we will be lucky to hear the summary of from two ministries, two major ministries that participate in this training workshop, from Ministry of Agriculture and from the Ministry of Planning. They will summarize what they will actually learn, the new skills, the new set of information, and how they will incorporate into their institutions' current work, and what are the additional information or skill that they would like to receive some more trainings or more knowledge. So for today, this morning, I will give the microphone to the new trainer from QED. So you can take your floor. Thank you.
What about presentation?
Yes.
Oh, I thought it will be later now, right?
Yes.
Okay.
Yes.
Okay. Okay. ឥឡូវយើងកម្មវិធីយើង feedback ក្តីដូចជាការ presentation ក្តីតើខាងកសិកម្មមុនឬក៏ខាង so Ministry of Agriculture first, eh? Okay. So I would like to invite the representative from Ministry of Agriculture to provide feedback and also share your information. Thank you.
Ada.
Okay. You mean laptop?
Bah. Muốn test đà đâu. Xe muốn share screen đà.
Okay. Yeah, he's working on it. Oh, there. Good, good.
Ai có mực hình bao nhiêu?
Nó được không xuống
Và
xuống có một xuống không
ai có khởi hình bao nhiêu na?
nó không xuống mặt khơi
Ok.
chẳng như chẳng phản năng này
Ở đây có mấy có khởi hình bao nhiêu mà?
lúc này
Chẳng ok bạn.
Okay, jam đây mà.
Nè.
Okay.
chẳng mày còn
Bạn ok ở đây rồi.
bạn
So hello, my name is Nachaya. I'm from agricultural zoning office. On behalf of the team, do some presentation about the progress that we progress of Cambodia crop mapping that we work on it. So the same Rice SDP for our crop work, we use machine learning for our work, but the workflow a little bit different from the Rice SDP. For that produce the rice, we use Google engine to do a sampling and to clean off our different data. Then we use TensorFlow to store TensorFlow, the output from the Google engine in TensorFlow and in the Google Cloud. Then we use Then we use AI platform using Google Colab to run the code of the TensorFlow and use TensorFlow build to as a library for build neural network to create model, and we transfer back the output to Google as engine. So our model to produce crop mapping, we use a CNN model. We can call it conservation neural network for our work. So here another example of our workflow. So the first step, we select the satellite image that we use, and combined with the reference data that we from the ground truth, and we upload and clean it in the Google engine, and then we process it with Google Colab and TensorFlow, and we can produce as a map. Yeah. So here is some example that we upload our data, the study area that and different data that we finish cleaning and updating, and we upload in Google engine. Yeah. So for the scope study, first we select the Kampong Thom province. We select because we select Kampong Thom province for our case study because as you know, conservation neural network requirement data for the random model is wall-to-wall coverage. So the plot that we have to work is 4 by 4 kilometers. So our sample is 10 plot. So one plot have a 4 kilometer by 4. Yeah. So for our fieldwork, for the fieldwork, to collect the different data, we have 3 different types. One, we have a questionnaire to collect the information of the field. We have X, Y of the point. We have information about slope, elevation, weather, the land use, land change of the area. Another, we use drone to capture for the whole area. And also we have to collect the points. So when we arrive the field, we divide the team in 2. One team fly the drone, and the other team do a questionnaire and collect the point. So after we come back from the field, the data that we had to prepare is for our work, we use 2 different satellite images. One we use Planet NIC-free, another one is Google Hybrid. So after we come back from the field, we had to download those images. And we also use Google World Imagery from ArcGIS and QGIS. And also the drone image, we had to prepare and the point that we got from the field. After we prepared all those data, we had to start to update our plot. So before we start to update the plot, we had to compare. Normally, we use planet different month. For planet, we use different month. We have to check 2 or 3 month combination. For example, like this is a drone image that we go to the field that we capture, and we compare with the planet imagery from January. But we had to compare 1 or 2 months, for example, like this. We see it's not changed. So we compare with the Google Hybrid. So after the area is not changed, we identify as a rubber. So we had to update the field as a rubber. So the process is repeat for the whole area, 4 by 4 kilometers, 4 kilometers. So we had to try to draw as much as detail for our different data. So after we got the point, we got identified with the drone image. Here, the final result of the plot have filled all information, not just cashew, but the village, the other crop, mango, cashew, cassava, maize, the whole area that have any information we draw as a reference data for us. So after we finish our reference data, we double check with the team to make sure that there's no error, and we agree together that the plot looks good. So we update all the information to the Google Earth and process with the TensorFlow and Google Colab to produce our map. So first, we try to produce only our study area. So we see a good result from our study area. So we decide to test for the whole country. So we know that some here the result that will be test it's clear, but it's good result, but it's still confused with some rubber and the plantation. So we know that after we try to run for the whole country, we know that some province is still confused with the model. For example, like Ratnagiri, it confused with plantation tree, and some other province is still confused with the long end. So we need to check with those province, and maybe we try to go to that province to collect more different data to see the model react with the information. So for our challenge is the most challenge is the imagery, satellite image that we use. For image that we use Planet. Planet is the most updated image. It's updated every month, so it's useful. But the disadvantage is it's not clear enough to identify the crop. So, and also the Google Hybrid the resolution is good, but it's not up to date. So it's challenge for us. For example, like this for the planet imagery, when we go arrive to the field, the cashew is the year around 1 or 2 or 3, but in the planetary is saw as a bare land. So it's quite challenging for us. But yes, we work on it too. So for our current activity, before the end of the year, we already collect other information for 3 provinces in Tabong Kumum, Stang Trai, Ratnagiri. So we already finished Tabong Kumum and Stang Trai. We have 1 more province left in Ratnagiri to update. So we try to update the information as soon as possible, so we can see the result of the most error province. So, and after that, we can identify the area that most error, and we decide to go to that province to collect more information. Yeah. And for now, we also do unbiased area estimation. And we also try to compare unbiased estimation for accuracy assessment and to follow up UNFCCC protocol, and try to compare with the math report, the value that we just finished. And yes, we need, so for now we try to, the next step for us is try to include high resolution image to the model, and to see if the high resolution image is the best approach that we should go, or we should continue the same work that we just done. Yeah. And also, so for us, it's the challenge is we just the department and also the equipment and transportation is quite challenge for us. Yeah. Thank you.
Thank you very much, Mr. Charya. Maybe since there's another, this is really interesting that I personally see that as what we have for the agriculture investment, like a climate-friendly agriculture value chain project is ongoing, touching upon this, the climate smart solutions for this, the cluster of the production area. But I don't think the project has used that sort of like the overview of this and then the real sort of nearly real information for this project planning and implementation. Maybe there's something interesting that we can do. So I would like to get you touching with this project officer and maybe we would like to have a conversation.
Is there any ADB assistant toward your work?
No.
Yeah, I think we have two major ADB projects. I think it's also related to cashews and related to, cassavas and all of that. One of Takashi's process and also another one is Shini. So I think we can talk on that later on. Thank you.
Thank you very much for the great presentation. Let's just give him a round of applause. Thank you. Okay, so can we have the next presentation? I think there's a plenty. Would you like to come over? Maybe you can assist him, no?
Okay, oh. ពីម្សិលឬសួរថាមានតែនិយាយទេឥឡូវមានដល់កុំព្យូទ័រទៀតចឹងមុខតែល្អហើយណាសូមចេញ
Maybe you can talk around it some of it.
Okay ខាងគ្នាយើងមានសំណួរមានអីចង់និយាយពេលចប់ពីគាត់អាចលើកឡើងបានណាមិនថាមានតែគាត់ពីរនាក់ទេយើងណាដែលមានសភាពក្លាហានហើយចង់ចែករំលែកសូមអញ្ជើញ មានខាងគ្នាយើងបន្ទាប់ពីកប់មានចង់លើកឡើងអីទៀតទេសូមលើកដៃមួយមើលហើយខាងនេះគេឲ្យលើកដៃមិនលើកអីវិញពេលដើរមកដូចកិច្ចមុខហ្នឹង
มันต้องได้ติดต่อนี่หมอนี่ให้วิดีโอโอเค បាទសូមគោរពសិក្ខាកាមដែលមានវត្តមាននៅទីនេះទាំងអស់គ្នាបាទខ្ញុំបាទតំណាងមកពីវិទ្យាស្ថានជាតិស្ថិតិរបស់ក្រសួងផែនការបាទនៅនយោបាយសេវាព័ត៌មានស្ថិតិដែលជានយោបាយថ្មីបាទហើយខ្ញុំបាទគឺអនុប្រធាននយោបាយនៅក្នុងនយោបាយនោះណាផ្លេចណែនាំខ្លួនឈ្មោះបាទខ្ញុំអាចសូមឲ្យគាត់បកប្រែសម្រាប់នឹងដោយសារនឹងសម្រាប់បាទសម្រាប់វគ្គដល់នេះបាទ Yes when I speak in Khmer it's okay yes because I can speak a little bit about English thank you បាទខ្ញុំបាទមកលោកសរិយាបាទជាអនុប្រធានយុវដ្ឋាននៃសេវាព័ត៌មានស្ថិតិបាទដោយសារយើងមានពេលវេលាខ្លីដែរហើយខ្ញុំមានព្រៀងខែមច្រើនទេតើតើជាមួយនឹងសំណុំនេះប៉ុន្តែអានេះជាផ្នែកនៃវិទ្យាសាស្ត្រដែលយើងបានផលិតបណ្ដាពីអាស៊ីបាទហើយខ្ញុំឃើញព័ត៌មានដែលយើងគាត់បង្ហាញថ្ងៃកន្លងនេះគឺតើតើសរុបគ្នាសម្រាប់សម្ដេចនេះដែរបាទអាចជានៃសិក្សានេះបាទ How about that? Các bạn đáng chúng ta về chuyện tầm này sẽ phải tại trong chúng mình sai test chó và bao giờ tầm này play ca rồi bỏ cơ xuông test chó chúng mình tầm này đại diện ai tiền bán từ online và tam là dạ Agoda booking hay Agoda hay là booking online nằm bây giờ tầm này nó compareគ្នាថាតើបើសិនបើយើងធ្វើ ទិន្នន័យទីយកមកពីអនឡាញហ្នឹងអាចយកប្រើប្រាស់ជាមួយនឹងទិន្នន័យដែលទិន្នន័យរដ្ឋបាលដែលមានស្រាប់ដែលបានរកអស់បាទហើយមួយទៀតហ្នឹងគឺតកតងជាមួយនឹងការវិភាគទៅលើទិន្នន័យការប្រើប្រាស់អគ្គិសនីនៅតាមបទបានជួយបត់ដែលមានការបដិបត្តិពី UNSCAP បាទហើយនៅក្នុងផ្នែកនេះគឺយើងមានទិន្នន័យពីខាងក្រសួងរាយនឹងធម្មពលដែរដើម្បីទិន្នន័យរដ្ឋបាលដើម្បីប្រៀបធៀបជាមួយនឹងទិន្នន័យអនឡាញដែលយើងត្រូវទាញមកប៉ុន្តែនៅទីនេះដោយសារពេលវេលាយើងមានតែ10នាទីអញ្ចឹងខ្ញុំបង្ហាញទៅតាក់ទងជាមួយនឹងវិស័យទេសចរបាទបាទពេលយើងមានទីមួយយើងមាន implementation challenge ហើយនឹង way forward តើយើងត្រូវធ្វើអីបន្តទៀតបាទតាក់ទងជាមួយនឹងការប្រើប្រាស់ទិន្នន័យសម្រាប់វិស័យទេសចរបើសិនតែយើងចង់ធ្វើខាងលើអនឡាញដើម្បីធ្វើទិន្នន័យនេះបាទហ្នឹងគឺយើងត្រូវការក្រុមដែលត្រូវធ្វើតែយើងត្រូវសមាជិកប្រមាណនេះដែលត្រូវធ្វើក្នុងនោះយើងត្រូវមានបាទហើយដែលយើងអាចធ្វើបាននោះគឺការប្រយោជន៍ scripting ពី Apple Google ដូចជាមួយនឹង Python បាទដែលពួកគាត់ឲ្យយើងវិញប្រាំហ្នឹងគឺវាស្មានតែគាត់មានវិធីការពីថ្ងៃទី1ដែរបាទហើយ website ដែលយើងមកប្រើគឺAgoda ហើយនឹង booking online ហ្នឹងគឺវាដោយសារវា mostly គេប្រើច្រើនបាទហើយអ្វីដែលយើងអាចធ្វើបានគឺដែលគាត់មកសន្តាគារមួយហ្នឹងបង្ហាញមួយជា CSV ហ្នឹងហើយយើងយកមកពិភាក្សាដោយប្រើកម្មវិធី Stata ហើយនឹង SPS បាទគឺជាទិន្នន័យដែលយើងទីមុនពី Agoda Booking បាទហើយនឹង Booking នេះបាទយើងមានប្រភេទសន្តាគារបាទយើងមានជា ID យើងមានឈ្មោះបាទប្រទេសរបស់យើងហើយតំបន់បាទទិន្នន័យនេះយកពីតំបន់ពីក្រុងបាទហើយ postcode ហើយមានប្រភេទបន្ទប់បាទមានជាចំនួនបន្ទប់ដូចថាសន្តាគារមួយនេះមានចំនួនបន្ទប់ប្រមាណបាទហើយមានតម្លៃនៃការប្រើប្រាស់បន្ទប់ហើយមាន room occupation rate ROR នេះមានន័យថាតើភ្ញៀវដែលស្នាក់នៅក្នុងសន្តាគារនេះមានប្រមាណ%បាទទំនេរប្រមាណស្នាក់នៅប្រមាណបាទអញ្ចឹងយើងអាចប្រើតាមរយៈ web scripting បាទហើយនេះគឺជាទិន្នន័យដែលយើងប្រៀបធៀបគ្នារវាងទិន្នន័យរដ្ឋបាលបាទហើយទិន្នន័យរដ្ឋបាលគឺខ្ញុំយកចេញពីរបាយការណ៍របស់ក្រសួងទេសចរបាទនៅក្នុងឆ្នាំ2020ប្រៀបធៀបជាមួយនឹងទិន្នន័យដែលពួកខ្ញុំទទួលការបដិបត្តិពីអាស៊ានហ្នឹងបាទនៅយើងយកតែខែ7ទៅក្នុងឆ្នាំ2022យើងឃើញថាទិន្នន័យហ្នឹងវាបើតាក់ទងចំនួនបន្ទប់សរុបដូចនៅខេត្តបន្ទាយមានជ័យហ្នឹងទិន្នន័យដែលយើងទិញបានពីអនឡាញនេះមានចំនួន 3800 បន្ទប់បាទហើយ3800 បន្ទប់ហើយទិន្នន័យដែលមាននៅក្នុងក្រសួងទេសចរនោះវាមាន2308បន្ទប់បាទអញ្ចឹងយើងឃើញថាទិន្នន័យហ្នឹងវាប្រហាក់ប្រហែលគ្នាដែរបាទហើយដោយសារយើងយកពីអនឡាញនេះគឺអានោះសម្រាប់តែសន្តាគារដែលគាត់ប្រើប្រាស់ភ្ជាប់ជាមួយនឹងបណ្ដាញដឹកជញ្ជូនអញ្ចឹងនៅក្នុងប្រទេសកម្ពុជាយើងមានគាត់អត់បានប្រើប្រាស់តាមនឹងទេអញ្ចឹងវាអាចមានភាពល្អឿនខ្លះប៉ុន្តែបើយើងទៅប្រៀបធៀបសរុបយើងឃើញថានៅខាងក្រោមនេះឃើញថាចំនួនសន្តាគារហើយនឹងផ្ទះសំណាក់ហ្នឹងគឺសន្តាគារដែលមាននៅក្នុងក្រសួង ទេសចរហ្នឹងបាទគឺមាន3824បាទហើយយើងជួយពីអនឡាញវិញមានរហូតដល់4183បាទសន្តាគារអញ្ចឹងយើងឃើញថាតនន័យនេះវាអាចវាមានភាពខុសគ្នាខ្លះដែរណាប៉ុន្តែបើសិនបើយើងជាអ្នកវិភាគតនន័យមានន័យថាថ្ងៃក្រោយទៅបើសិនបើយើងដឹងព័ត៌មានហ្នឹងយើងងាយស្រួលនៅក្នុងការទៅផ្ទៀងផ្ទាត់ជាមួយនឹងតនន័យជាក់ស្ដែងដែលមានស្រាប់អញ្ចឹងយើងធ្វើបើសិនបើមានការអង្កេតអញ្ចឹងរៀងរាល់យើងអាចធ្វើពីមុនយើងអាចធ្វើរៀងរាល់មួយឆ្នាំម្ដងឬ2ឆ្នាំម្ដងអញ្ចឹងដល់ពេលដែលយើងមានតនន័យតាក់ទងជាមួយនឹងដូចជា machine learning ដែលបង្ហាញស្ដីគ្នានឹងដែរនេះយើងប្រើអនឡាញនេះយើងអាចកាត់បន្ថយការប្រើប្រាស់ស្វ័យហ្នឹងបើសិនតែយើងមានតនន័យហ្នឹងប្រៀបធៀបជាមួយនឹងតនន័យដែលមានស្រាប់ហ្នឹងហើយយើងវិភាគតាមrandom forest នេះបាទហើយនេះគឺជាក្រាបខ្លះៗដែលយើងបានបង្ហាញបាទតើតើពណ៌ទឹកក្រូចនេះគឺតនន័យរដ្ឋបាលដែលមានបាទហើយពណ៌ខៀវហ្នឹងគឺតនន័យដែលយើងបានពី website បាទនេះយើងអាចយើងអានេះយើងធ្វើតាម QGL យើងបានតន័យហើយយើងបង្ហាញវាតាមរយៈផែនទីនេះយើងឃើញថាចំនួនសន្តាគារបង្ហាញតាមពណ៌ដែលមានន័យថាពណ៌ដូចនៅរាជធានីភ្នំពេញមានចំនួនសន្តាគារចាប់ពី41ទៅរហូតដល់1740ហ្នឹងគឺពណ៌ខៀវដិតហ្នឹងគឺបង្ហាញពីតនន័យសន្តាគារដែលមានច្រើនបាទហើយដូចនៅខេត្តសៀមរាបហើយនៅបាត់ដំបងក៏មានច្រើនដែរបាទហើយនេះគឺជាវិធីសាស្ត្រគណនាបង្ហាញពីចំនួនសន្តាគារចំនួនភ្ញៀវដែលមកទស្សនៈដែលជាប់រវល់ហើយនឹងទស្សនៈហើយចំនួនប្រតិបដែលជាប់រវល់ហើយនឹងចំនួនប្រតិបដែលបនេបាទហើយនេះជាព័ត៌មានដែលយើងបង្ហាញនៅក្នុងខែ7ដែលយើងបានទូលយកមកទៅហើយបូកសរុបមកបាទទូទាំងប្រទេសនេះបាទបាទចិត្តបាទអានេះដូចគ្នាដែរទេបាទយើងគ្រាន់បង្ហាញជាក្រាបទេថាទស្សនៈហ្នឹងមានយ៉ាងម៉េចបាទប្រៀបធៀបជាមួយនឹងទិន្នន័យរដ្ឋបាលដែរបាទបាទហើយនេះគឺជាបញ្ហា challenge ដែលពួកយើងបានជួបប្រទះហ្នឹងគឺប្រវាងគឺដោយសារអីដោយសារពួកខ្ញុំហ្នឹងតាក់ទងជាមួយនឹងIT នេះមាន skill នេះពួកខ្ញុំមិនមានកម្រិតនៅឡើយទេបាទហើយតាក់ទងជាមួយនឹង Python programming នេះគឺសម្រាប់ពួកខ្ញុំគឺអត់ទាន់មានសោះតែម្ដងបាទហើយទទួលការបណ្ដុះបណ្ដាលហើយវាថ្មី Python នេះសម្រាប់ស្ថាប័នពួកខ្ញុំគឺវាថ្មីមែនទែនហើយមិនទាន់មានការប្រើប្រាស់នៅឡើយទេប៉ុន្តែក្រោយពីការទទួលបណ្ដុះបណ្ដាលឃើញថាវាដើរតួនាទីយ៉ាងសំខាន់នៅក្នុងការទាញយកចំណីពីអនឡាញយកមកព្រោះខ្ញុំជឿជាក់ថាថ្ងៃក្រោយទៅយើងត្រូវការវាជាចាំបាច់សម្រាប់យកមកវិភាគទិន្នន័យបាទទាញយកទិន្នន័យពីអនឡាញនោះបាទព្រោះនៅរយៈដែលយើងទៅទទួលការបណ្ដុះបណ្ដាលពីនៅប្រទេសថៃហើយនឹងកូរ៉េហ្នឹងគឺឃើញថាគេបានដើរទៅមុខមុនយើងហើយបាទហើយប្រើប្រាស់កម្មវិធីនេះដូចគ្នាបាទសម្រាប់ទាញយកទិន្នន័យមកភាគហើយនេះគឺជាទិន្នន័យសន្តាគារភាពខុសគ្នាមានន័យថាពេលដែលយើងទាញយកមកពីសន្តាគារខ្លះអត់មានកូដទេបាទវាមានភាពខុសគ្នាជាមួយនឹងទិន្នន័យជាក់ស្ដែងខ្លះបាទបាទនេះគឺជាទិន្នន័យដែលយើងយកមកទាញបានហើយប៉ុន្តែវាមានបញ្ហាខ្លះបាទហើយយើងត្រូវការជំនាញការនៅក្នុងការជួយបណ្ដុះបណ្ដាលបន្ថែមបាទហើយដូចបញ្ហានេះអញ្ចឹងដែលខ្ញុំបានសួរវាក្នុងថ្ងៃទី2ថាតើតើជាមួយនឹងកូដដែលយើងយកមកប្រើហ្នឹងវាមានបញ្ហាក្នុងអំឡុងពេលសិក្សាយើងយកមកវិភាគប៉ុន្តែយើងយកមកប្រើបានហើយប៉ុន្តែរយៈក្រោយមកវាមានបញ្ហា Chẳng mà tôi đã nên bằng hát bao nhiêu thầy sau đâu rồi tôi sẵn không chơi nên bao nhiêu thứ nào của còn tay bát mà tôi hái dương thuê nó bằng ha dương thuê lên đảo bà hay một ngày nó cái sầm khăn à tôi đã dương tôi nên tôi đã tiên cho tôi là nói dương nhân đây đầm nạ cá tôi muốn cứ dương tiên do ai đi sinh ha kia mình muốn do màu sầm tôi đã tiên ban hái dương thầy ao câu này đây tôi thích để như phía bờ tê được gặp như không sắp đã có màu sầm đạn nơi không tha kia mười nữa bà vô màu bằng hai màu đậm nạ tiên không phải đáng đồng nhưng ban bằng hai không pha CSV thành đôi cùng nữa bà chắc là tôi nói tí nó bị trăm bá chẳng sầm nhạt dương thôi ca ở phiên nó không câu tí đây có thể là cái bằng hai là bây giờ bị phiên hà táo nhưng thiêu không sắp tầm án thiêu bò tê tầm án ngay tầm án nhưng thời cả này chúng tôi nó dương ngặt bởi sao tụi nhóm vừa admin skill khang nóng mà không ca pra này không ca hay chân hay là tầm này chúng tôi sao là báo bị error như thế này nè bạn chúng ai bởi sao ở được lại nhưng và trong mà nhân xưa việc mà đánh tha mà tôi đã bàn hái ta tụi nhóm ai thuê là một tiệm là bạn nếu cứ chưa với forward พอ ខាងយើងបានគឺយើងដើម្បីធ្វើកិច្ចការនឹងទៅបានគឺយើងត្រូវការបង្កើតកម្មវិធីមួយដើម្បីគ្រប់គ្រងវាហើយយើងត្រូវការ clean ពេលដែលយើងទិញតំណែងមកបានហើយយើងត្រូវការ clean វាហើយនឹងវិសាលាវាហើយត្រូវការ technical support យើងត្រូវការជំនាញការមកជួយដើម្បីមានវិធីសាស្ត្រយ៉ាងម៉េចដើម្បីប្រើប្រាស់តំណែងស្ថិតិនេះបាទហើយដោយបង្ហាញអញ្ចឹងនៅក្នុងនេះអញ្ចឹងវាមានមិនមែនមានតែវិស័យទេសចរមួយដែលយើងអាចធ្វើបានបាទដូចវាក្នុងបង្ហាញតទៅជាមួយនឹង live night time អញ្ចឹងអគ្គិសនីហ្នឹងក៏យើងអាចទាញយកតំណែងអនឡាញយកមកធ្វើជាមួយនឹងតំណែងរដ្ឋបាលដែលមានស្រាប់ដែរអញ្ចឹងក្រុមការដើរជាសំខាន់បាទអរគុណច្រើនបាទអរគុណសូមអរគុណ
បាទអរគុណច្រើនខ្ញុំអាចសូមសួរគាត់បន្តិចថាតំណាងរបស់យើងមកពីខាងក្រសួងផែនការអញ្ចឹងហើយយើងសិក្សាអំពីអូតែលអំពីអីតើវាមានអូខេអាចចាំមើលយើងនឹងភាសាក្នុងពេលក្រោយណា
បាទ
អូខេ if they want have any query
Okay, I think thank you very much for the feedback. Maybe we can discuss about some of the feedbacks in the last session. We have the Q&A from the training as well. In the interest of time, can we just move on to today's training program? Is that okay? Thank you very much for your presentation. Now, let me invite back the Matheus and Leah. Would you like to take on the microphone? Thank you.
Okay,អរគុណច្រើនណា
អរគុណច្រើន
Hello, so we just follow a quick technical setup and we are back on track. Sure. Okay. Okay, looks about right. Can you hear me? Okay, and now also the Zoom, yeah? Let's try again. Okay. Here's the video. Share screen. Sure. Okay, I think everything is in place. Could you confirm that this Zoom works? Okay. Oh, we don't see it. Is it? Okay. Okay. Okay, sorry for the delay, but everything seems to be in place. Okay, so we can start. Leah, maybe you can come over for the quick introduction. So we will start with the work that we have done here, which is mapping the rice paddies boundaries in Cambodia. But maybe first let's us introduce ourselves. We did a quick introduction yesterday, but maybe you can get it once again. So here's our team. So our idea is that we are building the data systems and AI to empower other organizations to pursue the health and agriculture SDGs, Sustainable Development Goals. We are a team of around 25 software engineers, along with data scientists and experts in agronomy and health, because we believe that in order to build successful software, you really need the people that know the domain and know the field that we operate in. So I'm a software architect at QED. I work here for over 6 years, implementing a variety of solutions. Here is Leah. Maybe you can introduce yourself.
Sure. Hello again, everybody. It's wonderful to meet you again. My name is Leah Goki. I'm an epidemiologist working for QED. Previously, I worked for the Centers for Disease Control and Prevention in Tanzania, East Africa, and I was also a Peace Corps volunteer in Zambia. So my experience is mainly in sub-Saharan Africa, and I'm very interested in the intersection of health and agriculture. Thank you.
Thank you, Leah. Okay. So let's begin with the presentation. So smallholder farmers, you all know the story. They generate 30%, over 30% of the world's food. They generate 80% of the food in the third world countries. And the health sector is directly related to the food security and the whole agribusiness. The income is $1 to $2 per day. And that's really the field that we want to target with our solutions, with our technology. So really, we need complex solutions and very complex end-to-end approach. We cannot just build solutions that will be used in vain. So we have built a variety of technologies to overcome the data scarcity. So what is the real problem? The real problem is that we don't have the data. We don't have the data to make the clear decisions and data-driven decisions. So that's what we try to work on. So the first technology that I want to talk about. So right now we will just recap of all of the technologies that we will use to overcome data scarcity, and later we'll go into further details. So that will be just a quick agenda, just a quick recap. Sorry. Okay. Oh, let me see. Yes, I'm going to see before.
On the internet from
Yeah, one second.
because the signal in
Yeah, but okay now. Is it okay? Okay, great. Okay, getting back. So the first technology I want to talk about is digital soil mapping. So what we did is that we partnered with AFSIS, the African Soil Information Service, to really gather the samples across in Africa, use the mobile technologies, mobile data collection to gather all of the soil samples. So what we really need, we need to dig in. We need to gather the ground truth data. We need to georeference that to really have the feedback from the soil, to really have the data, the information about nutrition and so on. And we need that georeference so we know that the nitrogen deficiency is in that region, and then maybe we can infer more information. So how do you know where to dig? That seems like an easy question, but if you operate on national scale, it's not really that easy. So we built the land cover mapping solutions for sustainable development. So we also know where exactly to dig in across the country and provide some randomized trials that we know where to gather the data in a randomized control way. So then we use the mobile data collection so that we can gather the georeference data that I mentioned and visualize this. So we know how it happens. What do we produce across the whole country? So having that, there are more issues to overcome. So not only the soil, but also you can analyze how does the plant health looks like. So maybe a quick question to the audience. Do you know what kind of deficiency the leaf has on the left, right? Any ideas? So here most likely. Okay, so in this picture is most likely the nitrogen deficiency. And what we try to do is that smallholder farmers and the people in place may not have the high expertise that agronomists do. So what we want to have is build the software that we can take a picture of a plant health, of a plant leaf, which may potentially have some disease, and then send that to headquarters where we have the right specialist to analyze the picture and then send the feedback back to the farmers about what is happening with the leaf, what kind of disease do we have. In this way, using the mobile technology, we don't need to travel to all of the remote places. We can just use for that the app, and we have partnered here with 1 Acre Fund to develop this solution and to deliver the data just to the farmers so that we exactly know what to do based on what kind of disease do we have with plants. And while here you can clearly see what is happening with the plants by the red-brown edges, it may not be always so easy to tell what kind of deficiency do you have, and not all of the changes are visible by human eye. So for that, we have been building portable proximal sensors, such as portable spectrometry, to address that issue and to really know how to analyze the plant in the field, not only in the lab, to gather data. That's a whole different story. We will talk about in more details. So for now, just a quick recap of what we're going to do. And then you may all ask that we use here a lot of technology. We use here mobile phones, and I'm sure that not all of the farmers have mobile phones, especially given the income. So how to do that? And not only that we may not have all of the sufficient mobile phones, all of the sufficient technology to deploy at scale. It also in the field, as you may know, with the scorching sun, you may not be able to simply use the phone. So what we do that is that we provide also technology on the paper, where we can scan the paper later, but fill in the actual paper form in the field, scan it later, and digitalize all of the data, so that we can really have all of the feedback, all of the necessary information from the ground truth. Okay, so that was a recap. Now let's jump back into objectives in Cambodia with the engagements with ADB. So the objective was to map rice paddies in Cambodia. We want to remotely generate polygon boundaries for rice paddies. We did that for the 9 selected areas, which were spanning across 16,000 hectares. And now I would like to get into how we did that remote mapping and what were the outcomes. But maybe first, why do we even need to do that? So why do we need to generate remotely all of the plot boundaries for the whole country? So the motivation is that we may want to do yield prediction. So how to do yield prediction if you don't know how much fields do you really have and across what area does it span? It's very hard. It's even hard without that, but that helps a lot. If we need further crop type mapping, it's much better to first generate all of the polygons, all of the boundaries of the plots, and then later, based on that, tackle the issue of crop type mapping. It helps directly with the land registration and the investment planning, so that we can implement the right agribusiness strategy based on where the fields are, where the agriculture is happening. Okay, so let's get to methods. So how we really develop that, how we tackled all the issues. Okay, so the methodology is as follows. So first, before we start with the machine learning, we really need to gather sufficient amount of samples of data. And we use that from satellite imagery. We do labeling. We do surveys where people in a crowdsourcing manner are marking where the plots are. So we do that for a subset of this area that we want to do, so that we can really know what the plot looks like, and that the machine learning later can infer the results. Okay, so we label all of the plots, then we do the model train. So based on all of the labels that we have gathered, based on all of the data that we have from the surveyors, we now try to train the model, the machine learning model, to infer the results. So to infer where the plots are in other places that we have marked. We do validation, and we do a cycle of such refinements until we come up with the results that are satisfactory. Then we do the inference on national scale for the whole country, and we deploy statistics, maps, and all of the really information, all of the indicators that we need for the further decisions to make. Okay, so let's explain a bit more how we do the labeling of the data. So we want to scalably annotate the imagery. we can use that we use that from the satellite imagery. We have developed a custom geo-survey application to do that. So the trained surveyors are marking where the fields are. We use that to rapidly train artificial intelligence. So here's how it looks like. So the geo-surveyor marks where exactly the plants are, the fields are, the plots. We may also mark where are the houses. And you can also mark where the forests are. If you want to just map the plots, we sure don't need the houses, but we can also use that data. So here's an example of the sample that one of the geo-surveyors made. So here's the blue rectangle, and within that area, the surveyor will mark where are the crops. So here are some more of the examples of how it looks like. So we randomly sample across the areas that we want to look for, and then mark where are the plots. So then we can use that information for the AI so that we know that this is how a crop looks like. So the important thing is that the surveyors may not have the required information on how really does a crop look like based on the satellite imagery. So I'm sure that all of you will not have troubles with identifying where the crops are with all of the expertise in agronomy, but it's not an easy issue to tackle. So in our software, we have administrative panel where we have employed agriculture experts that can review the data that is clean and also provide the right training for the surveyors so that they really know what to mark and what is really not interesting for us. Okay, so the right question to ask here is now, why not map just everything this way? Why not just label everything from satellite imagery? Yeah. So the reason is that there is 3 million of hectares of rice approximately in Cambodia. So the time to trace all rice paddies on a full-time work for one person will be 23 years. And that's just for 1 year. And we really need this map every year. So just calculating from the salary, that would be $160,000 US. Okay, and that's just for 1 year. And in order to make really good decisions, we would need that data to be every year, maybe every even some months. Yeah, we need to have a good solution that we can update based on the years, not that just we can generate once and then rely on for the next 50 years, because it really changes dynamically. Yeah. So that's why we really would like to use the artificial intelligence so that we can make it scalable and sustainable. So how to do that? So like I mentioned, we collect the data, we develop the right architecture for the machine learning models. Then we do the training and the right optimizations, and we validate the performance. Do we really get the outcomes that we want to have? So here's an input image and the desired output that we would like to have. So the computer vision is developing rapidly, and here are some of the ideas, some of the technologies that we may use. So for the image, we may do some image recognition. How much of the sheep do we see on the image? We may do semantic segmentation, where we really try to classify, label the different objects that are on the image. You can just put the boundaries, the rectangular boundaries around the objects, and you can do instance segmentation so that we really mark with different colors, with different classes, all of the objects which are on the image. So the architecture that we have been using is named UNet. So it's a machine learning model, is a machine learning architecture. And what really happens here is that maybe it's better to just see the image. So what happens here is that we start with the image. What is really an image for the computer? It's a matrix, an array. Array of arrays, a matrix of the pixels, and we want to really classify each pixel what it is. For example, in the semantic segmentation. So this architecture is allowing us to extract the features. So we run with a series of so-called operation named convolution, which is basically just simple math arithmetics like multiplication and addition, to extract the features, to extract the borders, to extract the boundaries of the image. So we really simplify the image because we just want the characteristics of it. We do that, and we also minimize, we also reduce the dimension so that we can do this at scale and we can do this in an efficient way. And then we use that information up so that we can infer where the boundaries are. That's not the only way. We have also tried other architectures, which I won't get into details right now, which we might use later. But so far, we have found that the previous architecture was performing the best. Okay, so the state of the art is taken really from other fields. So it's taken from surveillance, sports, military, autonomic cars. You may notice that, for example, the autonomic cars may use the object detection to really see what's happening in the traffic, but we can use that to agriculture development to mark, for example, houses or also the crops. So let's see some of the details on how we really performed, how the AI performed in Cambodia, based on our model that we have developed. What was the result really? So the metric that I would like to focus on is precision and recall. So the precision means based on our results, based on our inference, what percentage of that is actually correct. So this is the precision. And we have achieved 96% of that. But the precision alone is not sufficient metric, because let's say that we don't map any of the fields. Well, then we have precision 100% because all of these results are good. So we also need the recall. So the recall means that based on the true data, based on all of the plots that we have, all of the actual plots, what percentage of that did we map? And this this indicator is not also sufficient, because if you map everything as croplands, then we would have also 100% because we would map all of the croplands, yes? So that's why there is a very, very interesting metric, very useful metric means, which is F1 score, which is really a harmonic mean between the precision and recall. So that's the metric that we should really look at. And for that, we have 87%. Okay. So behind the numbers, what we really want to look like is how the mapping is performing in action. So here are some of the examples of our AI results. So this satellite image is on the left, and the AI results is on the right. Here's another example. You can see that all of the rectangles of the plots on the left are mapped in the AI. Of course, we don't have 100% precision, so we will lose something. But the general precision is 96%. So if we say that something is cropped, it really is likely that it will be. Okay. So that's just the results. Let's get into how we really visualize this for the whole country. So this is the map of Cambodia, and the selected regions that we mapped with partnership with ADB. So let's zoom in into one of the particular regions. How does it look like? So this is one of the regions. And here on the green, you can see all of the plot boundaries that we have generated. So this is the ground truth data. Well, this is the GeoSurvey based data. And this is what AI produced. So you can see how closely matched we have here. Okay, let's get through some other examples of how does the mapping look like. Here's a very close zoom on how the plots look like, and then the mapping from the AI. Okay, so here we have the summary statistics in Cambodia with the selected regions. We have the number of plots that we have produced. We have the total cropland area. And from that, we can generate the average size of a plot in hectares. Okay. I see some pictures taken, so I'll wait 1 second more on the slide. Okay. Okay, so that's just slides, but let's see the actual map. Okay, so here we have the map. Here we have the Cambodia, and let's zoom in. So what we see is that these are the parts we do mapping. This is one of the regions that we will zoom in. So this is Chamkarkoi, sorry for the spelling. So we see the total area for this particular region, the total cropland area, and what is the average size of a plot, which is 0.2 hectare based on our data. But let's zoom in to really see what the details are. So here is how it was mapped. And maybe let's just pan around the area to see in closer details. I can also toggle to see like that this is the satellite imagery. This is what the AI mapped. Let's check another region to see how it performed in other places. So once again, we zoom out to Cambodia and let's zoom to this region to see how it maps in really a different environment. Once again, for all of the regions, we have the information on the right about total area, total cropland area, and average size of a plot, which is quite similar, 0.22 hectare. Here are the results based on this region, which, as you can see, looks quite different from the other one. Nevertheless, the AI still got a very good match on how the cropland look like. Once again, you can toggle to really see that the boundaries are matching what do we have on the map. Okay. Let's get back to presentation. So what you probably would like to have is that this is our visualization that I just showed, but maybe you want to work with the tools that you already know. For example, state-of-the-art QGIS. So you can do that. So all of the maps that we produce are really in open access. So you can download all of the layers and you can just go and play around with that. So let me just get through this. We have this also on the slides on the presentation in case you would like to go through it later, but I think we can just go through it. So on the maps, okay. So on the map site, let's visit that. We have really all of the maps that we have done. You can go through browse maps. You will see all of the layers that you have, and you can go to Cambodia region. And you can see the AI evaluation. What you can do here is that you can download the layer. It's just here in the bottom left corner. I have already done this, so let's just use QGIS to display that. So in QGIS, you go to layer, data source manager, and then you just select the file that you have downloaded. Okay, so we can see that the data is now loaded in QGIS. You can zoom in and really apply all of your knowledge of the software to really play around and generate the statistics that you want to generate. Okay, so that's for the QGIS. But the thing that also in the previous days you learned about is that you can use Jupyter notebooks and GeoPandas to analyze the data. So you, on the training from thinking machines, you know how to really operate that with the Python. So can you do that with our maps? And yes, you can. So like you can simply, maybe let me zoom in so that you can see all of the code. You can import the GeoPandas. You point to the directory, and then one by one, you can import in the same way that you learn in training. You can import all of the layers. And then you can plot and really perform further calculation, everything that you learned about with GeoPandas on the layers that you have. So I won't go through all of the possible actions that you can do, but I'm sure that now you have some familiarity and some perspective on what can be done right now with that, like calculating the area, calculating average plot size, and so on. Okay, so with that final remarks, I would like to open the discussion session. You can ask questions, and really let's talk about what we have done here. So right now I'm giving the voice back to you.
I think you have a lot of questions. I think there was a mumbling all over. There are a lot of tables. Who wants to come first? Just for the clarification for this example of this Cambodia one, there is a 9 irrigation. There was a Rice SDP. There's irrigation investment is the most part of it. So we just map all the project area. It's a rice command area scattered around the different provinces. No question, really? Yes, go ahead. Participants first.
សូមជម្រាបសួរអ្នកនរគ្នាបាទខ្ញុំបាទឈ្មោះពុនសកុនធាមកពីយុវដ្ឋានដំណាំស្រូវនៃអគ្គនាយកដ្ឋានកសិកម្មបាទ
I'm sorry, could you go once again because I didn't have the headphones.
ខ្ញុំសូមអរគុណច្រើនចំពោះបទបង្ហាញនេះខ្ញុំគិតថាវាមានសារៈសំខាន់សម្រាប់ការកំណត់ផ្ទៃដីផលិតកម្មដំណាំស្រូវទូទាំងប្រទេសបាទ ហើយសំណួររបស់ខ្ញុំហ្នឹងគឺខ្ញុំសំណួរទី1ហ្នឹងខ្ញុំចង់សួរថាតើការធ្វើផែនទីរបស់គាត់ហ្នឹងគឺផ្អែកទៅលើរដូវប្រាំងឬក៏រដូវវស្សាព្រោះយើងឃើញថាផ្ទៃដីហ្នឹងវាអាចវិបាកប្រែប្រួលតាមរយៈរដូវប្រាំងនិងរដូវវស្សាបើសិនជាយើងទាញរូបពីផ្កាយអំណត់មកហើយជាវាមានភាពខុសគ្នាហ្នឹងសំណួរទី1បាទហើយសំណួរទី2ខ្ញុំចង់សួរថាតើលទ្ធផលដែលគាត់បង្ហាញមកហ្នឹងតើមានបានប្រៀបធៀបជាមួយ national data ហ្នឹងតើវាមានភាពខុសគ្នាកម្រិតណាបាទព្រោះជាទូទៅតាមភូមិឃុំឬស្រុកហ្នឹងគាត់មានទិន្នន័យផ្ទៃដីស្រែរបស់មកហើយហ្នឹងតើទិន្នន័យដែលចេញពីអាជ្ញាធរនិងទិន្នន័យដែលប្រើ satellite image ហ្នឹងតើវាមានភាពខុសគ្នាកម្រិតណាបាទសូមអរគុណបាទ
Okay, so I see that the question is twofold. So let's first get into the first part, which is the wet season versus the dry season. So, okay, let me get the image. So what we use here is that we are using Bing images, Bing maps to use it for training on the data. And Bing Maps, as well as Google Maps, have the great advantage of having 0.3 meter resolution. Okay, so that's very close. Okay, and the disadvantage with that is that Google Maps, and as well as Bing, the one that we use, does not provide the actual timestamp on when the image was taken. So it is claimed to be, for example, from 2020, but this can be really from some other time. So we really don't have the exact information, whether that was in the dry season or in the wet season. So that's an issue. And you could say that we could refer to Planet Labs, for example, but for the planet, the resolution is 4.7 meter. So it's really not enough. The resolution is not high enough to achieve the good results from the AI. You could also use Sentinel satellite images, which also have these timestamps, and you can say that you want data from 2021. But then once again, the resolution that you have is 10 meters, which is once again not satisfactory. There are some other companies, for example, like Maxar images, which have very good resolution images, and also the timestamps. So that's great. But the cost is out of this orbit, like their satellites. So in order to sustainably map this for the whole country, we really cannot go for this, or we would need really the incredible funding for that. So we have also been flying drones. We also have apps for flying the drones. So that's a great question. But what we find out that, as you will learn later, we have also mapped the croplands for the whole Nigeria. So Nigeria is incredibly big country, and to fly drones through the whole area would not be really a feasible solution. So with the drones, you can get high quality imagery, but we found out that to do this at scale, at national scale, this is really not possible. Okay. Mm-hmm. Okay. Yeah.
Okay. I'm from Preveng. I'm implementation support specialist for the Rice SDP. ខ្ញុំចង់យ៉ាញ់ខ្មែរដែរបាទខ្ញុំចង់ចូលរួមបន្តិចពាក់ព័ន្ធនឹងប្រព័ន្ធទាំង3និង4ដែលបានបង្ហាញហ្នឹងជាពិសេសចំការគួយអនសោងនិងអន្លង់ចាបាទខ្ញុំចង់លើកចំណុចកន្លែងហ្នឹងដែលគាត់បានគូបានបង្ហាញនេះគឺដោយសារតំបន់ហ្នឹងគឺត្រូវបានចុះបញ្ជីជាលក្ខណៈប្រព័ន្ធដោយក្រសួងដែនដីចុះបាទអញ្ចឹងខ្ញុំចង់បញ្ជាក់ថារាល់ទិន្នន័យដែលគាត់បានគូឬមួយបាន overlap ទៅលើផ្ទៃដីដែលនៅក្នុងប្រព័ន្ធមួយហ្នឹងតើវាស៊ីគ្នាជាមួយនឹងទិន្នន័យ ឬមួយចំនួនក្បាលដីដែលទទួលស្គាល់ដែលចុះបញ្ជីដោយក្រសួងដែនដីហើយនៅបាទព្រោះអ្វីដែលខ្ញុំធ្លាប់ធ្វើការងារនឹងដែរគឺកាលណាយើងគូនៅលើនៅដៃហើយនៅលើពត polygon ពតអីហើយយើង export ឲ្យហើយជា list ជាអីហើយបានយើងចុះទៅ verify ជាមួយអ្នកភូមិជាមួយអាជ្ញាធរដែនដីទៀតដោយឡែកករណីប្រព័ន្ធនៅរំលេចនៅស្រុកសិទ្ធរកណ្ដាលប្រព័ន្ធរំលេចហ្នឹងគឺទើបតែចុះជាប្រព័ន្ធទេអញ្ចឹងមានន័យថាកន្លែងហ្នឹងក៏អត់តន់ច្បាស់ដែរអញ្ចឹងគាត់ចង់ដឹងថាតើចំណុចទាំងពីរហ្នឹងតើយើងមានបានផ្ទៀងផ្ទាត់គ្នាប្រៀបធៀបគ្នារវាងទិន្នន័យផ្លូវការរបស់ក្រសួងដែនដីហើយនៅបាទសូមអរគុណ
Okay, so we have not done this comparison, but we are very happy to assess our results against the data from the Ministry of Planning. So if we could be provided with the data, we would be much happy to really do this assessment. But right now, we have not done it. Yes, exactly. So if you have this this grant through data, what we really can do is that we can use that for the machine learning to really infer the further results based on the results that you have that you will provide to us. So that will only increase the precision and the general accuracy of the system. So that information will be really valuable to us.
Hello, thank you for the presentation. So for the first part on the methodology, when you try to annotate the polygons, how did you decide on how to sample the areas for which you will get training data for the model?
Okay, so what we did is that we have 9 regions here. And we took 7 regions for the training data and 2 regions for the test data. So what we did is that the test data was Ramleh and Chamkarkui. So that was, okay, so maybe let's get a little bit of background information for the people about the training versus test. So you can also ask, how did we got the numbers of the precision and recall? So some sample of the data that we collected is used as training. So that's what we train the machine learning. And then to test what is the performance, we cannot use the training data because then we could just overfit what we have in the training. So we use other regions to assess what is the performance, which we didn't use in training. So the question is about what is the division between the two. So for the training, we use 7 regions of the 9, and 2 of the regions we used to test data, and we tested that based on Ramleh and Chamkarkoi. So that's why I really wanted to show you the 2 examples, because that was used as test data. So this was the actual inference of the AI, and we did not train on this.
Okay, one more follow-up question. In terms of satellite imagery, what would you say about the cost of using high-resolution satellite imagery deployed across an entire country, especially when you're constrained that, I mean, for example, a timestamp problem. So how did you factor that in? And not, for example, you could have used something like NICV, but it would have been 4.77, but you could have had a timestamp. So what were your considerations in terms of working around what's available, the cost and availability of satellite imagery?
Okay, so could you say once again the name that you
the
imagery?
NICV 4. Another option, Planet NICV 4.7.
So from what we see, the Planet Labs have 4.7 meter resolution. So for the smallholder farmers plots and to generate the boundaries, we found out that it was simply not enough.
Anybody else? Sorry, one question about this. You show the demo or the plotting, right? And then our request was to plot the individual rice paddy field. But I noticed that in the past, and there was like picking all the points. What can you actually mark from this exercise? I mean, if it's not just for the agriculture, we have land use planning people, agriculture people, with the different purposes of the use of the map as well, right? So what is visible? What can you mark? There's like did you pick hospitals or building or something like that?
Yes.
Can you express what you can do?
Exactly. So that's a great question. So we have, in other project in Nepal, we have been mapping all of the houses across the whole country as well, using the same methodology, using the same principles, that we will mark boundaries of all of the houses. And based on the rooftops that you can see from satellite images, we will infer where the houses are. And we also use the OpenStreetMap data to plot the roads and the ground truth data of the agro dealers. But it will be in the next presentation where I will go through that in details, and I will show also the examples of how we mapped all the houses, how does it look like. So that will be also further explained further later in the presentations, in the later blocks. So this is also similar to the problem of crop type mapping, where you also want to identify what crop is. And that's also valuable information. You want to differentiate between maize, wheat, and rice, possibly. So we also try to do that in Nigeria for the crop type mapping. And we find out that this problem is pretty hard, that we can do that. And we have some numbers on that that I will show later. But in general, the crop type mapping is a hard problem. And really from the satellite imagery, even under high resolution, it is pretty hard to get the exact crop type. And we have not tried with different types of houses to map, for example, where are the hospitals, where are the other buildings. But I think that the problem is equally similar, especially since from the satellite imagery, the only data that you have is the rooftop. So it's really hard to see if that's a rooftop of a factory or of a hospital. Yeah. Yes, Leah?
Yeah, just to follow up to Michiko's question, we actually can distinguish between thatch roofs and metal roofs, which can offer, some proxy measure of wealth. Just wanted to add that in addition. Thank you.
Yes, the size of the house we can also detect, because we get the exact boundaries of the house. So we can see if that's some bigger factory, that's some bigger building, or if this is just a small building, small house. Yes, that you can have.
Yeah, every polygon in the data is a separate closed shape that can be marked. So.
I have more questions, but are you going to talk about the soil nutrients or something that is a sampling that you mentioned in the very?
Yes. Regarding the other agriculture technology that I have put in the agenda, I will also talk more. So right now, yes.
Any other questions? If not, maybe if you want to break.
Yes. Okay. So maybe we take. Okay. So maybe a 10-minute break for a coffee, and we start 10:30. Okay. Great. In Nigeria, we have they were collecting I was in Nigeria. Yeah, there are. Can do this. Where we don't have here.
I think this is those data on one's education team, like polygons.
Oh, you mean from the surveyors' data?
Yeah.
So we really got a fleet of surveyors that are trained based on the recordings. So we have agronomy experts that were making some videos on how to do that. And then we have really a fleet of surveyors which are mapping that. So we can really do this even on a bigger scale in a quite quick time.
Before I used to do that before. I'm a field surveyor too.
Yes, yes. So we really have a lot of people which then are trained based on the agronomy experts to really map all of the fields. So that can be done.
The detailed data if we think about the owner, the plot owner, like name,
yes,
the resident.
Yes, so this is the land registration, and what we also can empower that here is that usually the data will be collected on paper.
Yes, that's right.
Yes, so then you will go across all the places, collect the data on paper, and then we also have technology that we will explain later in the presentations, where you can just type in everything on the paper form, then take a picture with the phone later on.
Yeah, you can
collect it from the yes, and then we do optical character recognition. So we recognize all of the writing that is there from the boxes, all of the numbers, and then we digitalize it.
Even that while you on that, you enter the household information.
So we have not been running this kind of trials, but if there's an organization that will be interested in it, what we really like to do is to empower them with the technology that will facilitate doing this.
Yeah. Maybe we have to need more steps to do that.
Yes, exactly. Yeah.
Yes, because we have to export the table, export the table from GAFSP, to Excel
Mhm.
and to use the table to show the farmer the name, the style of the plot,
Yes.
and and the location is right or not. And sometimes we have to merge
Mhm.
the plot boundary 2 or 3 into 1 something.
So we have been running this kind of trials with partnership with Simit. This is the wheat and maize wheat and maize organization that is running a trial across the whole world based on their plans on the tea, which is based in Mexico. So what they do is that they really send the samples to the farmers, to the places where they need, and then run the trials on how the teas are performing. And also we have been collecting the feedback on how was that performing from the paper, which we will digitalize.
Sometimes I think that sometimes another way of the data source could be find that could be download for that. I just some location like Hangzhou or Nongcha, like that. You can download or you can get distinct data from the land management, the state of land management data source, and then you can verify and overlap.
Yes, that would be really amazing if you could really use also the data that you have to perform the validation. And if there are mismatches, then we can really see where the mismatch is and how we can build better software so that we can accommodate the mismatch. So the more granular data and the more cooperation we have, that's basically better.
Yeah, sometimes we call it budget, like project.
Yes.
Yes, thank you.
Thank you. Thank you.
của anh yêu thương bạn của mình anh cùng với đầu tiên anh tôi trong này cây cu bóng ăn này còn tại nữa quyền phải kết bạn của con gái dạ đó mặt đây luôn đó mình tại nào cái luôn rõ đường phải một chút ồ tôi nói cho tâm linh vật tâm linh vật có thì thì là chỉ một làm lấy điều lên bạn muối đấy
Yes, yes, no problem. Yes, not a problem at all. Yes, everything is ready. Okay, maybe just 1 more minute for everyone to see it and get comfortable. Okay, so let's get to the next session. Please wear your headphones if you need to. Okay. Okay, I see that sharing on Zoom is on and the audio works. So, okay, let's start the next session. So right now we will go further, not to just limit ourselves to plot boundary, but not to just specify on the plot boundary, but in general, the crop mapping and the mobile data collection that we have mentioned before in the agenda. So we have been working with other companies in general to focus on the sustainable development goals. And as there were also many questions about the related technologies and the related applications, we would also like to talk about with a focus on the agriculture. So we'll showcase some of the mobile apps, web apps, even the mechatronics and spectroscopy. And later, Leia will also discuss some of the paper that we can also digitize. So now we'll move on to a little more basic problem, which is cropland mapping. So we could see this as a subset of the previous one of the plot boundaries mapping, but right now just the croplands without marking the exact boundaries. This problem is a bit simpler, but I would say it's a great basis for doing the later boundary mapping. So we could do first cropland mapping out of all of the crops, and based on the crops that we have, later infer where the exact boundaries when the crops are. Okay, so we'll talk about the other work on cropland mapping that we've done. So what's the problem? Why even work on that? So in the middle graph, you can see, well, in the graphs, you can see that on the yellow, there is the actual yield that we have achieved. On the red one is the yield gap. So the calculated yield that we could obtain, but we just don't have yet. Each bar is representing different fields on different year. And the 3 plots which we have is respectively from Kenya, Nebraska, and Australia. So in the middle one, in the yield performance from Nebraska, you could really see that they are pushing themselves to the limit of what they can achieve. They have a lot of funding, a lot of sensors, plenty of fertilizer, and they really can achieve what is possible out of the crops. But in the places in the sub-Saharan Africa, such as the Kenya that we have here, we can see that the potential, what we can achieve is really far from what we are getting. So there's room for improvement. And we know that it is possible to get better, but the question is how? Like, what can we apply? What tools can we use? What data can we use to drive towards better yield? So I'm sure that you are all aware of the use of the fertilizer and the importance of that. So the Abuja Declaration, Abuja, Nigeria Declaration of Fertilizer in 2006 was that we want to achieve 50 kilograms of nutrients per hectare of arable land. So the status right now, in almost after 20 years, is that we only use 8 kilograms per hectare. And that's, in Africa, 3% of global consumption of fertilizer is used in the 20% of the world's arable land. So it's really not sufficient. And we can see now where the yield gap is coming from. So the cropland mapping work is really necessary to provide us with the information of hectare of arable land to really calculate on what status we are with the fertilizer usage. So one of the use cases that we have been working extensively with is Nigeria. Is a really big country with 200 million of population. The economy is larger than Africa. And it used to be the food is highly imported because of the oil that they have discovered. So right now it's the main export for Nigeria. So the UK ministry in 1977 have done some maps, some legacy crop maps, but they were really saying about the subset of the cropland that we had. They were not really fine grained, and they didn't have all of the required information about the crops, where they are. So in a very similar pipeline, in a very similar methodology, we have done the national scale cropland mapping for smallholder agriculture system for the scale of the whole Nigeria. So just a recap of the methodology: we take the satellite imagery, we do the surveying to label all of the, well, not all of the, to label sufficient data samples so that we can learn on, use the machine learning, and then produce national scale maps and statistics. So we label the imagery. And in the case of Nigeria, really because it is a big country, it's very diverse also. So we have worked with agronomists to divide it based on agriculture, ecological zones, and political boundaries, so that we can really get the good data. So in the south, the type of crops and the land is much different from the north, which is close to Sahara. So it really differs. So what we did is that we stratified based on the agricultural zones, provide the training in each of the zones, collected the samples from each of the zones, and then trained on that based on the zone. And this remote sensing is paired with field work, which we also find really crucial. And we have run a fleet of motorcycles to cross-check that what we are seeing from the space is really matching what we have on the ground. That combined with the collaboration of soil scientists and construction of the agricultural zones, can really give us good guidelines for the surveyors so that we can really have high quality label data and then later to use the machine learning to infer that. Because with the very good quality label data, your models of machine learning will really not perform well. Okay, we use the artificial intelligence, like we said, to learn the patterns from a variety of examples. And we mapped croplands for the whole Nigeria. So the accuracy and precision was 85% on the national scale. And here we actually used the spatial resolution 10 meters, which was from the planet imagery from year 2020. And what we did is that we have been updating that also in the next year. And here, with just the cropland mapping, the spatial resolution of 10 meters was satisfactory for our use case. So here are some of the examples. But maybe once again, let's see how it looks like in practice. So once again, here's open access Nigeria map that every one of you can play around with, and we can see in details how does it work. So here is the mapped cropland. Here is the image. And here is what was mapped by the AI. Okay, let's get back to presentation. So we've been mapping both plots, which you can see on the left-hand side, the before and after, and as well as the buildings, which we have also been talking about briefly through the discussion session. Since we have, like I said, been deploying the maps, using the model to infer both for 2020 and 2021, we can actually check what was the change, what was the difference between that. So here, we have a difference of what happened between on a span of 1 year. And here was the case of change induced by a man-made dam. So you can see that how the river overflowed on all of these areas around, which really affected the crops, so that you can see the difference on the red that it was subtracted it was subtracted on the map. So this kind of spots can be detected automatically based on the map. Okay. So, oops. So from this map, what we really want is to make data-driven decisions. If you look at from the sky, you can really see that there is a lot of croplands, and it's not yet enough for us to make a good data-driven decisions. So what we want is statistics. So we have been generating maps which have all of the statistics necessary divided by the geopolitical zones, so that we can really make decisions based on the area that we focus on. Okay, so in this map, based on the color, the more intense color is, the more percentage of the croplands is in the area. You can see the map both for 2020 and for 2021. You can use kilometers or hectares. And then if you hover over one of the zones, on the left-hand side, you can see in the geopolitical zone, for example, Kaduna in Nigeria, what is the total area of that region, what is the cropland area, and we have also calculated the percentage of the crops in that place. You can hover around, and you can also zoom in so that you can see really fine-grained information about small zones and where the croplands are and where they are really not. You can see that here, cropland percentage is 0.44. So probably means that this is just some bigger city. You can divide that in the states, but here in the case of Nigeria, we also wanted to have the information based on the geopolitical zones, northwest, northeast, and this kind of division you can also show in. Okay. Let's get back to slides. So our cropland maps, which we have generated for Nigeria, as I mentioned, but we also done it for Ghana, have actually been merged into Africa Fertilizer, which goal is to provide an objective source of key performance indicators for the African fertilizer sector. So on the africafertilizer.org, you can see our you can see the use case of our maps. Okay, another use case that I have briefly mentioned during the discussion was in the Nepal. So we have collaborated here with Nepal Seed and Fertilizer Project to build a comprehensive map of the agricultural ecosystem in Nepal. We have here interactive maps of all of the croplands, of the buildings, soil, roads, and agro dealers. And agro dealers was provided us from the grant proof data. So basically, with the ministry, we worked to know where the agro dealers are, and we have also mapped that on the in the app. So maybe you can show that. Yeah. So this was partnered with also with CIMMYT and the USAID product. Okay, so here's the map. This is for Nepal, and let's zoom in to see how it looks like. So here we have croplands roads from OpenStreetMap. We have buildings and the agro dealers information. Okay, let's zoom in. Okay, I see the network performance here is slowing us a bit down, so let's zoom out a bit. Okay. Okay, I see that the network is slowing a bit down, but maybe we can, okay, we could be able to zoom in. So here from the rooftops, you can see that all of the buildings are marked and the boundaries of the buildings are marked, as well as we have the roads, which were provided from the OpenStreetMap. And we have mapped the buildings for the whole country as well as the croplands. Okay, let's get back in. So how was that used? So this map was adopted into the national policy. So the maps were used, were officially integrated into agriculture statistics used for National Fertilizer Subsidy Program by the Prime Minister and Minister of Agriculture and housed at the Nepal Agriculture Research Council. So you have paired with the Minister of Agriculture to make use of the maps of all of the data available. So we cannot overemphasize the importance of grant proof data and how key is it to all of the projects. So let's get into how it was collected. So we have the mobile data collection. And what we did here is that in the ABSIS project, Africa Soil Information Service, there were run soil surveys, which were going around the country and collecting the soil samples. Then using the mobile app, we were providing the georeference metadata about the soil so that we can know from which part of the country the sample came for. And then we can use that to later know that, okay, in this part of the area, we know that we have nitrogen deficiency based on the lab tests that we have performed and based on all of the lab analysis that we have done. And that georeference information is really crucial for us. So with the data gathered in Ghana by our partnership with Africa Fertilizer Agrobusiness Partnership, so the AFAB project, so the AFAB was supported by our digital tools of the mobile data collection so that we can really create visualizations of the drivers of the buildup of the fertilizer costs from the start until the end of the market. So in this visualization, you can see what was the initial price from the factory of the fertilizer. And then you can see along the way where the costs were building up and which are the biggest contributors to that. You can see that the added margin, the shipping charges, the logistic costs, here are the big bubbles, which means that they have contributed a lot to the overall final price. Okay, so let's go to yet another use case of technology and mobile data collection that we have done here. So once again, you can see that there is a picture of a leaf. And you really can see that there is some issue with that. So once again, like I said in the agenda, the smallholder farmers may not have the required expertise to know what kind of disease is that and what action to perform based on that. Should they put more nutrition? So should they change the fertilizer? So this kind of expertise can be provided by the agronomy specialists, but it's really not scalable for them to drive around all of the plots across the whole country and provide them expertise, because usually you have only a few of them. So what we have done here is that what we call the plant telemedicine. So you can submit the photos with the mobile app of the plant, and then once again you have a survey on what happens here. So you can see in the survey on the right is that the upper leaf. Whether there are any other colors, you can select which kind of color it is. If there are any holes, and what kind of reason is for that? Is it the stem borer? Is it fall armyworms? Or is it some different? You can mark there are tears along the edges. And then the agronomy experts sitting in the offices can really analyze data collected from all of the country and really in real-time fashion respond to that issues and then give feedback about what should be done with that. So once again, another example of that, of crop health issues that can be geospatially identified based on the images that we have taken, which also have the georeference data. We have done some building help menus. So when you want to select what color do you see in the lower parts of the leaves, you also have some examples to see how does which of the cases looks like to guide you through the process. Okay, that's all that we wanted to say right now about the other agriculture use cases. I would like to open now a short discussion session once again. And after that, we'll move on to another session about handheld spectrometry to further analyze the samples, the leaves. But now let's maybe have a quick discussion session about what was talked right now. So back to you. Are there any questions from the audience?
សូមគោរពស្ថានភាពយើងទាំងអស់គ្នាបាទខ្ញុំមកពីវិទ្យាស្ថានជាតិស្ថិតិនៃក្រសួងផែនការបាទខ្ញុំចាប់អារម្មណ៍លើបទបង្ហាញនេះខ្លាំងដោយសារអ្វីដែលស្ថិតិត្រូវការគឺធ្វើយ៉ាងម៉េចដើម្បីទាញយកទិន្នន័យហ្នឹងយកមកប្រើប្រាស់ជាមួយនឹងទិន្នន័យផ្លូវការបាទដោយគាត់បង្ហាញតាក់ទងជាមួយនឹងតំបន់កសិកម្មអញ្ចឹងដើម្បីបានតួលេខពីតំបន់កសិកម្មតាមរយៈការទាញទិន្នន័យពីអនឡាញនេះមកបានហើយយើងឃើញការសម្រាប់ពួកគាត់បាទហើយយើងស្គាល់ម៉ាស៊ីន learning នេះសម្រាប់អ្វីដែលខ្ញុំឆ្លងកាត់នេះគឺទៅតែ2019ក្រោយ COVID នេះទេដែលវាជាផ្នែកមួយនៃ big data បាទហើយវាដើរតួនាទីសំខាន់ណាស់តាក់ទងជាមួយនឹង data digital នេះបាទតាក់ទងជាមួយនឹងទិន្នន័យដែលយើងទាញមកពីដំណាំប្រភេទដំណាំតើយើងមានវិធីសាស្ត្រយ៉ាងណាដើម្បីអាចធ្វើការប្រៀបធៀបជាមួយនឹងទិន្នន័យដែលយើងបានពីជំរឿនឬក៏អង្កេត survey បាទដោយសារបច្ចុប្បន្នបើសិនបើយើងមានស្ថានភាពដូចកាលពី COVID អញ្ចឹងយើងជឿថាមន្ត្រីនៅក្នុងការប្រមូលទិន្នន័យនេះគឺមានការលំបាកណាស់ហើយអញ្ចឹងតើយើងត្រូវធ្វើយ៉ាងម៉េចអញ្ចឹងទិន្នន័យ digital នេះដើរតួនាទីសំខាន់ដើម្បីកំណត់ពីប្រភេទនៃដំណាំឧទាហរណ៍ថានៅខេត្តកំពង់ចាមប្រភេទដំណាំកស៊ូតើយើងអាចដឹងថាដើម្បីបានទិន្នន័យថាវាគ្របដណ្ដប់លើផ្ទៃដីប្រមាណហិកតាបាទអញ្ចឹងគឺផ្អែកលើអ្វីដែលវាគ្មិនបានបង្ហាញនេះគឺមានសារៈសំខាន់មែនទែនបាទហើយដូចនៅខាងតំបន់ខ្ពង់រាបវាមានព្រៃតំបន់ព្រៃអភិរក្សបាទតំបន់ដែលប្រជាពលរដ្ឋអាចធ្វើកសិកម្មបានអញ្ចឹងវាត្រូវកំណត់ទៅលើប្រភេទពណ៌នៃដំណាំមួយអញ្ចឹងហើយដើម្បីបានដឹងថាវាគ្របដណ្ដប់លើផ្ទៃដីប្រមាណហិកតាបាទហើយខ្ញុំជឿថាខាងកសិកម្មគឺពួកគាត់ត្រូវការព័ត៌មាននេះខ្លាំងណាស់ក៏ដូចជាការប្រើប្រាស់ជីស្ថានភាពជីដែរបាទឆ្លងកាត់ការអង្កេត survey កន្លងទៅភាគច្រើនដូចនៅខាងខេត្តស្ទឹងត្រែងខាងអីចឹងបើសួរគាត់ថាដីគាត់នឹងត្រូវការប្រភេទជីអីគឺគាត់អត់ដឹងទេបាទអញ្ចឹងតើនេះគឺវាសំខាន់បាទហើយវាតកតងជាមួយនឹងតម្លៃប្រើប្រាស់ជីគាត់ថាស្ថានភាពរបស់គាត់ប្រសិនបើគាត់ប្រើប្រាស់ជីហើយគាត់អត់ដឹងថាដីរបស់គាត់នឹងត្រូវការជីប្រភេទអីទៀតអញ្ចឹងវាចំណាយថ្លៃដើមច្រើនបើប្រៀបធៀបជាមួយនឹងផលិតផលដែលពួកគាត់ទទួលបានបាទអញ្ចឹងខ្ញុំជឿថាបទបង្ហាញមួយនេះគឺសំខាន់មែនទែនបាទសម្រាប់វិស័យកសិកម្មដើម្បីយើងអាចធ្វើការកណនាទៅមុខទៀតថាតាមតំបន់មួយតើត្រូវការសក្តានុពលនៃការប្រើប្រាស់ជីយ៉ាងដូចម្តេចបាទសូមអរគុណ
Okay, thank you for the question, for the feedback. So, yes, the COVID really affected the way that we gather the data and the way that we want to operate that. And you can see that remote sensing is the use of satellite imagery is even more important. And actually, all of the work that we have done in Nigeria was just at the outbreak of the COVID. We have traveled there just when it happened, and then we're on some quarantines because of that. But so what we have done here is that we had this fleet of motorcycles that were really checking that the data that we have from the satellite imagery and data that we saw online is really matching what we have on the ground, as well as team up with the agronomy experts that gave us feedback on what really was there. So that is one thing. The part with the fertilizer and well, the part with the data collection. Let me see where it was. Yeah, the part with data collection, it was held, and the mobile data collection was held on the ground, gathering the samples. and the information about the fertilizer we wish to use. So one idea is that using this plant telemedicine and how the plants are responding to what you put, you can really give the feedback on what's happening, as well as maybe you would need actually some tools, some lab techniques to measure on place what really deficiencies do we have. And maybe you need some tools that you should take the laboratory just to the field to measure that. And with the current setup, it might be not scalable, not affordable. But the next session, we really would like to show a device that you can use for handheld spectrometry, so that you can see what is the spectrum produced by the leaf, and what kind of deficiency in the leaves do you have, and then based on that, apply the correct fertilizer. So that's what we like to also showcase in the next session. I hope that this answers your question, and
ជាបឋមខ្ញុំសូមបង្ហាញឈ្មោះខ្ញុំឈ្មោះម៉ៅឈឹមមកពីវិទ្យាស្ថានជាតិថេតិឃើញគាត់បង្ហាញហ្នឹងគឺគាត់បានធ្វើការ survey យកតំបន់សំណាក់គំរូហ្នឹងតិចអញ្ចឹងសួរថាតើវាអាចតំណាងឲ្យបើយើងគុណនឹងវេទៅតំណាងឲ្យប្រមាណភាគរយនៃផ្ទៃដីកសិកម្មព្រោះខាងខ្ញុំនេះគឺវាមែនតើគេហៅថាបើស្រុកខ្មែរឃ្លាំងផលិតទិន្នន័យឃ្លាំងហ្នឹងមិនមែនឃ្លាំងតូចតាចទេឃ្លាំងធំស្តង់ដារអន្តរជាតិហើយបើកសិកម្មវិញយើងបានធ្វើពី2019សហការជាមួយ FAO ហើយជាមួយនឹងប្រូក្រាមរហូតដល់គេហៅថា2030គុណ50ណាហើយឡើយនេះនឹងធ្វើចប់នឹងផ្សព្វផ្សាយមកអវៈហើយនៅអវៈនេះកំពុងតែ clean ទៅណីហើយយើងនឹងមានជំរឿនកសិកម្មមួយទៀតនឹងធ្វើខែ4ហ្នឹងខ្ញុំកំពុងតែសរសេរមានញួរហើយនឹងរៀបចំ questionnaire នឹងចុះ pre-test ចុងខែហ្នឹងឯងអញ្ចឹងទិន្នន័យដែលគាត់ធ្វើហ្នឹងអត់មាន sample ដើម្បីថាជាតំណែងអាចយកជាការបានហើយកម្រិតលំអៀងយ៉ាងម៉េចហើយបើខាងខ្ញុំវិញធ្វើត្រូវយកប្រមាណហោប្រមាណតំបន់គិតជា4តំបន់ហ្នឹងតើតំបន់មួយហ្នឹងយកប្រមាណតំបន់ទន្លេសាបផ្លាតូ coastal អីចឹងណាចឹងគ្រប់ជ្រុងជ្រោយហើយមុននឹងទៅធ្វើគឺមានន័យថាយើងពាក់ព័ន្ធក្រសួងពាក់ព័ន្ធជាពិសេសក្រសួងកសិកម្មមកក្រុមការងារ involve ហើយជំនាញការ file នៅនឹងទៀតហើយដាក់ទៅឲ្យវា C ទៅនឹង SDG ទៀតអាហ្នឹងចឹងហើយដល់គោលដៅរបស់គេហ្នឹងគឺធ្វើឲ្យវាប្រើប្រាស់បានទាំងអស់គ្នាតែឃើញរបស់គាត់នេះដូចsample ដូចដាច់ហើយដូចរបៀបថាទឹមតេះចឹងណានឹងសូមថាមានព្រៀងទាត់ជាមួយខាងស្ថាប័នជំនាញកសិកម្មរបស់រដ្ឋាភិបាលទៅទេអរគុណ
Okay, so basically, the more data that we can collect and the more data that we can obtain from the ministry and the more statistics we have, only the better. We wish for the collaboration with the ministry, and really without that, our predictions will not be satisfactory. So doing that is only the best. And if you have more data that we can use, that's only the better. So as for the sample, we have collected 1% of the land that we have mapped. And to represent the diversity, we have, for example, in the case of Nigeria, we have done the stratification that we've done separately the different agricultural ecological zones. So if you have some metrics for the Cambodia, for example, where you know that the plots will be different, for example, in the north and in the south, then we can also use that to gather more suitable data samples and really to stratify based on the expertise from the agronomy. So that's what we did in Nigeria, that we have divided into different regions, and for each region we have done it based on the underlying sample, so that we do not use training from the fields close to Sahara in the much different fields which are in the south. So that's what we have been doing in Nigeria due to the big diversity of the country. Okay. Leah has also some feedback that you can share.
Yeah, just in addition to what Mateusz has said, we develop randomized sampling frames for evaluation on both the ground and through remote sensing. We make sure that they're representative by sampling from each of the agricultural ecological zones. And we also try to design these sampling frames in a practical way that the motorcyclist can access. Since we sample all over the country, both with the motorcycles and then through the satellite imagery. Okay.
បាទខ្ញុំមិនសូមអនុញ្ញាតចូលរួមបន្តិចតាមពិតហើយគ្រាន់តែជាការចូលរួមហើយប៉ុន្តែអាចជាការយល់ឃើញមួយផ្នែកបានតាមពិតអ្វីដែលគាត់បង្ហាញនេះជារួមបាទជារួមគឺជាការបញ្ជ្រាបការយល់ដឹងទៅលើការងារគេហៅថា data analysis ហើយ data analysis ឬមួយ AI របស់គាត់ដែលគាត់បានបង្ហាញនេះគឺកត្តាចម្បងគឺគាត់ចង់ឲ្យយើងប្រើហៅ technical បញ្ជ្រាបក្នុងការងារ projection របស់យើងតើយើងត្រូវបញ្ចូលអាការងារហ្នឹង apply អាការងារដែលគាត់បានបង្ហាញនេះទៅក្នុងការងាររបស់យើងយ៉ាងម៉េចដើម្បីជំនួសឬមកកាត់បន្ថយការប្រើប្រាស់ហៅមនុស្សបាទហើយគេធ្វើការងារនេះជាទូទៅគឺគេធ្វើការងារ prediction ទេមិនមែនជាការងារជាការប៉ាន់ប្រមាណជាការប៉ាន់ស្មានទេមិនមែនជាការងារយើងយកតួលេខពិតប្រាកដណាមួយដើម្បីឲ្យដូចជាការងារយើង survey ផ្ទាល់ទេបាទហើយមួយទៀតយើងអាចញែកគ្នាឲ្យដាច់ជាពីររឿងការងារ social និងការងារ technical អានេះជាការងារ technical ចំបាទប៉ុន្តែវាត្រូវការព័ត៌មាន social ដើម្បី support ដែរដើម្បីធ្វើការផ្ទៀងផ្ទាត់ដូចគាត់ថាប្រើម៉ូតូដើម្បី access ទៅដល់តំបន់ហ្នឹងដើម្បីទាញយករូបភាពឬមួយដើម្បីទាញយករូបភាពពី satellite អីដើម្បីមកផ្ទៀងផ្ទាត់គ្នាអញ្ចឹងហើយដោយរឿងរូបភាពជីរូបភាពដំណាំដែលគាត់បង្ហាញពីពណ៌ខុសគ្នានៃស្លឹកដំណាំដើមដំណាំហ្នឹងគឺគ្រាន់ជាកត្តាមួយនៃចំណោមមួយនៃកត្តាផ្សេងទៀតដែលគាត់ត្រូវបង្ហាញថាតើយើងយកអាហ្នឹងមកវាតម្លៃដើម្បីគណនាទិន្នផលឬមួយគណនាហៅថាកត្តាលូតលាស់របស់ដំណាំបាទអញ្ចឹងវគ្គនេះជារួមគាត់ថាអ្វីដែលគាត់បង្ហាញនេះជារួមគឺគាត់ថាដោយឆាយាគាត់បង្ហាញព្រមិញអញ្ចឹងគឺថាការងារនេះគឺដើម្បីគាត់អត់បានប្រៀបធៀបគ្នាទេបាទគាត់អត់បានប្រៀបធៀបគ្នាថាតើតំបន់ណាដែលគាត់បង្ហាញនេះតំណាងឲ្យតំបន់ណាទេអត់ទេមានន័យថាចាប់យកមក0ប៉ុណ្ណាដើម្បីយកមក survey ដើម្បីថតរូប auto photo ពីលើអាកាសអីហ្នឹងយកមកសិក្សាហើយវាយតម្លៃហើយ predict ថាតើតំបន់ហ្នឹងវាទិន្នផលប្រមាណឬមួយគេដាំអីខ្លះបាទក្នុងតំបន់ណាមួយហើយយើងត្រូវធ្វើអីយើងត្រូវធ្វើ project អីឬមួយយើងត្រូវ restore កន្លែងហ្នឹងយ៉ាងម៉េចទេបាទអញ្ចឹងខ្ញុំគ្រាន់សូមចូលរួមហ្នឹងបាទសូមអរគុណ
Okay, so what we really want to do is not to substitute, but rather to empower with the technology the current existing processes and really put more data in the places where we didn't have or where the manual labor was just too much and overwhelming. So with the use of the technology and of the machine learning, we really want to empower the existing organizations with the data that they lack. Yeah.
Matthias, maybe you can walk us through about this fertilizer example in terms of application from the eyes of the government. For example, they want to subsidize the nationally that use of the fertilizer, to encourage the more use of fertilizer in the context of Nepal, right? So, and you map out where the plots are and where all the input, the suppliers are in the logical, I mean, is it all over the countries? And how did you make that the fertilizer available at the doorway and actually encourage the farmers to use it? So that's sort of like what you have collected and showing the map that it's, yes, visible. There's a policy issued in a national level that is visible, so make it affordable maybe. But in between, how do you push this? I mean, for the agenda being that more fertilizer utilized to increase the crop yield, right? So if there's something that, that's the sort of like application story that would really be relevant for many of those audience here.
Yes, so we have used combination in the case of Nepal, we have used the combination of technology and the grant for data that we have from the ministry. So for example, here, we mapped the croplands and the buildings, but the locations of the agro dealers that were in the Nepal, we got from the ministry. So we used all of the information also available in the ministries and plotted that in our map to really combine the best of the two. So with the maps, we try to provide the information so that you can do the best investment planning and the best implement the best agribusiness strategy. Yes, yeah. So we try to give you the information and empower you with the information so that you can make the best decisions about the fertilizer, about the policies, and what to do with the data.
Actually, this information provided, for example, the extension workers at the district level so that they will efficiently move around in a target of the populated area, for example, or share that information with the input distributors so that they can do the better business of selling their fertilizer, or how, see, this is something that is, it's beyond your task, yes, I know that, but that's a core part of it. You know, without this information, you know, you're just like looking for a switch in a pitch dark room. You don't know where to go. But with this information in the hands of the right people, you'll be able to effectively address the issue of crop yield improvement, right? By the fertilizer. So that's the sort of the things that I was sort of like trying to explain as listening to you.
Yes, yes.
Yes. Yeah, okay. William, do you want to come in?
Yeah, can
Mark?
you guys hear me?
Yes.
Yes, okay. Yeah, thanks for the question. I just want to contribute a little bit to the discussion. So one of the issues in this project was that a lot of the fertilizer that is available to most Nepali farmers comes from a few parastatal institutions that are not necessarily the most efficient. So we know farmers have issues in getting their fertilizer on time, or maybe they never get it, or it's in the wrong quantities. It's not necessarily the right place, the right time, the right nutrients. So one of the goals for this USAID funded project we worked on was to try to further stimulate the private sector for both fertilizer and seed. And in order for the private sector to expand into the market, they need more intelligence. Where should I expand exactly? What are the needs? What kind of fertilizer is needed where? What kind of seeds are needed where, right? So you need to have this map like Mateus was showing to help them strategize entering the market in a larger way. So just one simple example is when we were mapping everything, when we map all the houses for smallholder farmers, we also then we have the locations of agro vets and agro dealers who could be delivering inputs, seeds and fertilizer. So you can start calculating, then combining with OpenStreetMap, how many kilometers would a farmer have to travel to get the fertilizer and seed that he or she needs, usually that she needs. And if we want to then sell to the market, where's the nearest place that I would be able to sell my crops or get financial help to take the loans or do other financial activities as necessary in order to become a successful farmer. So that's what I think a lot of this information brings, is this geospatial intelligence, so that all of these market agents could try to play the game more optimally. Back to you.
Great, thank you. Thank you for your intervention, Will. I think that's made it clearer. You okay with this? Shall we move on? Any more questions? Let's move on then.
Okay.
Thank you.
So now we move on to the next session part. Okay, so now we would like to talk a bit more about spectroscopy method that you are probably all aware of, which is a crucial aspect of the laboratories. And the goal is to make it portable, affordable, and adaptable to the conditions. So what's the inspiration coming from? So by working on numerous soil and crop development projects in Africa, we saw that analytical chemistry, wet chemistry, dry chemistry needed everywhere, but is really unaffordable and inaccessible. So on the left side, you have a picture of inductively coupled plasma mass spectrometer, which is an amazing device and is a very complex machine. And right now is the gold standard performing the element analysis of soil and plants. The accuracy is amazing, but also the price is skyrocketing up to $250,000 US. It requires stable electricity, which we found that in the sub-Saharan Africa, you might not always have. And many of the countries don't even have one. And to run the trials on national scale and collect many samples is really not a sustainable way to do this on a big scale. So instead of struggling to build labs in environments where it's very tough and manage the logistics of shipping samples from the field to the lab, our goal is to use the hacker way of making the small lab and bring it to the field. So what we need here is that we need equipment which is portable, which is affordable, and which has the precision that is good enough for the practical decisions, like, for example, the choice of the fertilizer. So we focus our skills on spectroscopy, which analyzes the properties of soil, plants, through the interactions with the light. And this is one of the fundamental tools in laboratory research. So one of the early inspiration for us was the public lab spectrometer, which is a do-it-yourself kit crafted from paper and using your mobile phone that you can use basically the spectrometry using your phone camera. So after running our experiments, we wanted something, we aimed for something more with a more consistency and better performance, but still affordable. And we have built our own spectrometer with production-grade components, improving the resolution, signal to noise ratio, building an enclosure that can be taken to the field, and also expanded beyond the RGB spectrum into near infrared. So in the early days, we have been playing around in the garage with using razor blades and PCV pipes. We have been using some Raspberry Pi's components and just playing around and seeing what are the options and what can we really achieve. So we arrived at this spectrometer, which is named Scan Spectrum. So the spectral range is from 400 to 1000 nanometers. The resolution is 3 nanometers. So that's the precision at which we can collect the samples and see where the bumps are. The measurement time is very quick, it's 4 seconds. It can work on transmittance using the standard cuvettes that you know from the laboratory, as well as reflectance mode. If we need to take that to field, we need it to be lightweight. So this whole kit, with the case included, is just 860 grams. And as for the power, it just uses power bank that you may all of you have. So we don't create our own batteries. We try to use existing ones for the more eco-friendly approach. So the first mode that it can operate in is the reflectance mode. So the reflectance is when the light shines into an object, some of that is just reflected in a specular manner, just like you see the reflectance on a car with the different light. But some of the light is really diffused and interacts with the material. And the reflectance of that light we would like to measure. So that's what we do. And in seconds, the scan spectrum device can measure the diffuse reflectance, from which a lot of properties of the leaf can be examined. We operate also not only on visible light, but also on near infrared. And from that, we can calculate the NDVI indicator. So as for the accuracy of measurement, here's the standard test of measurement of a spectrum of CFL bulb, which is a compact fluorescent light bulb that you can see on the right. And on the graph, they're plotted both the true data and the one that we have measured. And you can see that it really matches that. Maybe on the slide, you even can barely see the difference between the two spectra. It's very easy to use. The measurements that you take, you can later export to CSV files. And you have an app that connects with your mobile phone to use the scan spectrum device. But the talk is cheap, so maybe let's show how it is. Leia, could you? Yes, that would be great. Okay. You have the phone connected. Are you connected to my network? Just 1 second. Okay. That's good. Yes. Okay, so we assembled the device. As you can see on the bottom, you have a regular power bank. Here, you have all the computing power that you have in your pocket. So we just use the standard Android phone that we connect to the device. So on the screen of the presentation, you see what is actually visible on the phone, so that you can all see what is really happening, what is happening behind the curtains. So Leah, could you connect it? Okay. So using that, we will measure the reflectance of some of the leaves that you can find. Okay. Okay, so we need to connect the spectrometer to the phone. And then we will do the calibration. Then we will calibrate based on the standard parts that we have included in the spectrometer. Sorry, the screen sharing is crashing sometimes. Okay. So we'll be using the white background for the calibration, which is included in the kit. So at the beginning of the day, you will need to calibrate the device based on today's environment, today's humidity. You need to calibrate that once in the beginning. The device is calibrated, and now we can do the scanning of the sample. So what we have here is we have two leaves. The first one is the healthy one, and on the second one, you can clearly see that something is wrong. So let's first get with the healthy leaf. So to measure that, we put a black. You can show maybe the black thing. We show the black ring that you can use to put it behind the leaf, so that we don't get any other disruption based on the environment around us, and that we make sure that only the leaf is being scanned. Okay, let's see. So the scanning is taking place, and in seconds, we have the spectrum of the sample. Maybe you can name that the healthy leaf for our later reference. You can change the name based on your data sample. And we have already calculated NDVI, and you can see the graph of the spectrum that we have. You can show scroll. Yes, and here you can see the produced spectrum of that leaf. So we can see that the NDVI value is 0.74, which, as probably you know, it indicates that the leaf is healthy, the vegetation is great. And maybe now what we can do is to try to see what is the difference when we try to scan the leaf that is clearly diseased. Once again, we do the scanning. And once again, in seconds, you have the another sample. Once again, you get the spectrum. And the NDVI calculated here is 0.2, which really it really proves that it's not a healthy leaf and that the vegetation is not so great. So now what we can do is that what we want to do is to compare the two spectrums. So after you have taken the samples, you can also select both of them and then compare. You can compare any number of samples, and you can see the difference in the spectrum between the healthy and the unhealthy. leaf. And also from the NDVI values, you can also infer what is data. So that's the comparison of the spectrum. This is saved on the phone. It's not saved on the device. And then you can export all of the data to CSV format, to open readable formats that you can use really anywhere, import to Excel, or use in any other analytics that you would like. Okay, so that's the end of the demonstration. Thank you, Leah, for assistance. Okay, so that was what happens right now. And what we want to show is some other examples of what we have done with this scan spectrum device. So like we said here, you can measure also, here it was very visible that there was a big difference in the leaves with the bare eye, but also we can measure the plant stress. So for example, we've taken a fresh weed leaf, and we've taken a weed leaf that was sitting for a few hours in the room temperature. So visibly, they do not make such a big change. But when you analyze the spectrum, you can see above the 700, 750, so in the near infrared, so in the spectrum, which is not visible to human eye, that there is a difference, and also the NDVI reflects that. Another use case is the plant nutrition. So the spectral range that we use, up to 1000 nanometers, can also be used to determine the chlorophyll and the total nitrogen level in the leaves. So combined with the spectral modeling, it can enable to perform the early detection of nutritional deficiencies in the leaves before we can see the human visible difference. Scan spectrum can also, along with other indices, be used to identify which, to help with the breeding and help the breeders to identify the varieties that have the great performance potential. Once again, using the refractance mode. So in CIMMYT in Mexico, we have partnered with CIMMYT in Mexico, where we have been working also on the food integrity. So there are different types of maize, and the blue maize, from which the blue tortillas, which are made from the blue maize, are sold for the premium prices. And that is because of the antioxidants and the nutritional content that they have, as they have a higher protein content as well. So as you may imagine, on the market, they are often faked with the dye ones. So they dye with a blue-pink their tortillas so that you can see the blue flour. So what we have tested against is that on the left-hand side, two of the graphs that you see just here, you can see the spectrum on the left, on the far left of the scan spectrum, and then of the 80,000 near infrared spectrometer at the lab. And what you can see is that the bumps are matching from our spectrum, and that when we test that also against not only the blue flower, but also the fake blue flower, you can see that on the $80,000 spectrometer, you can see the two bumps. And in the scan spectrum, there are two bumps also visible. So we can detect when the two bumps are occurring. And based on that spectrum, we can see whether the tortilla that we use was the actual blue flower or was it faked with dye. Moreover, as for the not only food integrity but also food safety, we can do the scans to differentiate between calcium hydroxide levels which are distinguishable between the spectra. And based on that, we have less chances for neurotoxin presence in the tortillas, in the leaves. So, moreover, we can characterize the fertilizer performance. Where with the SADAGRO, we have tested with different fertilizers with mineral and experimental fertilization, and you can see also the difference in the spectra between the measurements. Moreover, we can measure the moisture content and use that information for harvesting silage. So based on that, we can estimate when is the right time for harvesting, as once again, based on the moisture content, the spectra are distinguishable. Yet another use case for the soil carbon. So our model, so on the table on the right, you have different analytes, pH, carbon, nitrogen, phosphorus. And you can see the modeling results and the R-square metric, which is used to assess the performance of the model and how well the model fits the data, how well does it explain the underlying variance. And we can see that with the full range and with the laboratory equipment, we can have the R-square of carbon 0.95. But with the scan spectrum, the handheld portable device, we have also achieved very high results of 0.88. And same with the nitrogen, where the results are, where the model fits very well to the truncated spectrum that we use, which is only from 400 to 1000 nanometers. Okay, so that all was used for the reflectance mode. But the other one is that there's also wet chemistry. So we also would like to measure the transmittance mode, and based on the analytes, based on the sample that we have in the standard cuvette that you use in the laboratories, what is the absorbance of the substance inside? So what you do is that in the scan spectrum, you have one tip, which is for the reflectance mode, but you can also exchange that in no time for the transmittance mode. So in transmittance mode, you have a second tip, which is also included in the pack, where you can input a cuvette and then gain the support of colorimetric analysis of the samples. So what you can do is that having for example, soil, you can mix it together with water and the color changing region that reacts in the proportion to what is the analyte content, for example, the carbon. Then you pour that into cuvettes and use that in the scan spectrum so that you can analyze the concentration of the sample, for example, of the carbon in the cuvette based on the transmitted light that we can measure. Another use case of that, we can measure the water pollution with that as using the transmittance and how much the light is absorbed. You can measure the turbidity of liquids, so the kind of cloudiness, which can be measured directly in the transmittance mode. This has use cases for environmental protection, water quality, and in general for industrial engineering. We have a variety of current and scheduled research. So we have been doing in Poland a model estimation for leaf nitrogen in maize, wheat, and oilseed rape. We have done some models for measuring the moisture content for maize, for silage, and the usability of the fertilizer sellers. In Mexico, like I mentioned, we have been detecting fake tortillas and testing tortilla quality. In UK, we have been doing various studies on genotypes of cowpea under different lighting conditions. In China, we have done the study of predictability of stomatal conductance. And in the Tanzania, our partner is working on methods to assist the plant breeders of selecting the right germ plants and the right seeds that is resistant to the diseases that are occurring. So to go through the summary, we have a portable and affordable device which uses the common phones and power banks, which has two modes of both transmittance and reflectance, resolutions of 2 nanometers and good signal to noise ratio. The data that we export is open readable format that all of the scientists are familiar with, which is CSV. It has the light bulb and two LEDs. It was tested to predict the spectral vegetation indices, the food quality, liquid colorimetry, and really anything scientific research that can be done with visible and near infrared spectrometry can be done. So using this device, we can deploy it at scale to the smallholder farmers so that we can, at a low cost, but also competitive quality of the results, we can deploy that at scale. And we no longer need the very expensive equipment that is used in the lab. Well, we still can have that, but for deploying this at scale to the smallholder farmers, we need something more affordable and that can be taken to the field. Okay, right now I would like to open more questions. Here you have some links that you can check if you would like to see more information and inquiries. And I'm opening the session for discussion once again and for the questions.
ជំរាបសួរខ្ញុំបាទឈ្មោះសុកចន្ទថនមកពីយុវដ្ឋានដំណាំពូជខ្ញុំចាក់អារម្មណ៍តាក់ទងទៅនឹងឧបករណ៍ដែលបានបង្ហាញអំបញ្ញមិញតែយើងអនុវត្តជាក់ស្ដែងនេះចង់សួរថាតើយើងអាចយកស្លឹករុក្ខជាតិដតីផ្សេងទៀតចូលមកប្រៀបធៀបជាមួយនឹងរុក្ខជាតិមួយទៀតហើយបង្ហាញនៅទិន្នន័យនៅលើទូរស័ព្ទបានដែរទេបាទហើយមួយទៀតតើឧបករណ៍ scan speak term ហ្នឹងថាតើវាអាចពិភាក្សាទៅលើគ្រប់សរីរាង្គរបស់ដំណាំដែលបានទាំងអស់បានដែរទេបាទសូមអរគុណព្រោះមិញយើងយកតែស្លឹកយកមកពិសោធន៍បង្ហាញជាទិន្នន័យ
Yes, so basically with this device, you can measure the spectrum of really anything. So it's not limited to leaves. Anything that you can zap with the device can be measured, and then you can measure the spectrum. So you can even point it to human skin and see what is the spectrum of the human skin. You can put it to some blue color and see that the spectrum will be indeed blue. So we are really not limited to leaves. This is one of the use cases that we opt for, but really the question is open. What else is possible? So we have the portable spectrometry device and really anything that can be measured for the spectrum. And then if you can get the data, if you can get the models, and if you can partnership with that, that will be great. Yes.
Hello. បាទតើតើនឹងការបង្ហាញឧបករណ៍នេះខ្ញុំឃើញថាឧបករណ៍នេះមានសារៈសំខាន់មែនទែន ប៉ុន្តែខ្ញុំជឿថាពេលដែលយើងប្រើប្រាស់ឧបករណ៍នេះខ្ញុំឃើញមាន region សម្រាប់ calibration បាទអញ្ចឹងអា region សម្រាប់ calibration ហ្នឹងខ្ញុំជឿថាសម្រាប់ស្រុកទេសសម្រាប់ប្រទេសរបស់ខ្ញុំប្រហែលជាពិបាកនៅក្នុងការរកពេលដែលយើងមានឧបករណ៍ហើយប៉ុន្តែយើងត្រូវការ region សម្រាប់យកមក calibration ហើយយើងត្រូវការតេស្តវាហើយការប៉ះទៅដល់សម្រាប់តម្លៃផលិតតម្លៃសារធាតុហ្នឹងសម្រាប់នៅនេះហ្នឹងគឺវាមិនជាថ្លៃប៉ុន្មានទេប៉ុន្តែអ្វីដែលសំខាន់តើយើងត្រូវទៅរកវាយ៉ាងម៉េចបាទហើយយើងត្រូវតាមតម្រាំដល់យើងកំងហើយ request ហើយតម្រាំដល់ម្ដងសម្រាប់យើងប្រើប្រាស់ហ្នឹងវាត្រូវការពេលវេលាទៀតបាទហើយបទពិសោធន៍ខ្ញុំធ្លាប់នៅផ្នែកទីពិសោធន៍នៅក្រុមហ៊ុនមួយដែរបាទអញ្ចឹងនៅពេលដែលប្រើ spectral សម្រាប់តេស្តធាតុមួយហ្នឹងត្រូវការធាតុហ្នឹងហើយនៅពេលដែលយើងប្រើអស់យើងត្រូវការធាតុហ្នឹងយកមក calibrate បន្ថែមទៀតប៉ុន្តែនៅពេលដែលយើងត្រូវ request ហ្នឹងយើងត្រូវចំណាយពេលច្រើនហើយមួយទៀតតាក់ទងជាមួយនឹងក្រុមហ៊ុនបាទក្រុមហ៊ុនហ្នឹងគាត់ធ្លាប់ support ហើយប៉ុន្តែពី3ឆ្នាំឬក៏5ឆ្នាំក្រោយមកគាត់លែងប្រើទៅលើគាត់លែង support ទៀតហើយមកពេលអញ្ចឹងយើងអត់ដឹងថាត្រូវទៅរកអាស្មារតីហ្នឹងយកមកប្រើប្រាស់យ៉ាងម៉េចបាទហ្នឹងគឺជាបញ្ហាមួយសម្រាប់ស្រុកទេសយើងហើយតែស្មានមួយត្រឹមតែឧបករណ៍សម្រាប់វាស់ PA meter ហ្នឹងទេបាទគឺត្រូវការធាតុនឹងពិបាកណាស់បាទហើយបើនៅដូចនៅថៃមួយអីស្រួលទេប៉ុន្តែក្នុងប្រទេសយើងគាត់នៅតែការវាគឺពិបាកមែនតើហ្មងបាទសូមអរគុណ
Okay, so there are two modes. So just to precise, do you mean the calibration of the reflectance mode, or do you mean for the transmittance mode? Just to make it on the same page. Leia, maybe you can. Okay. So as for the transmittance mode, what we have been doing is that, for example, with the water pollution or really anything that you have the sample in the cuvettes and you want to measure the color. So what we do here is that as for calibration, we would have the pure water as one of the cuvettes. So there is no sample, no sample at all. And then we would have, just like you do in the lab probably, is that you have the cuvette with a certain amount of the sample of the analyte, and then you have, for example, let's say you have four samples: 0%, 100% of an analyte, 50%, and 25%. And based on the 4 or 3 samples of the analyte of the true data that you know about, you can calibrate the device and you can have the curve based on which you do the later measurements. And then based on the curve that you have set in the beginning in the lab, based on the 0% solution, 100% solution, 25 and 75, for example, you can have the curve and then do later experiments with the analyte that you do not know what is the percentage of, and then you can plot that on this in the transmittance mode. And as for the reflectance mode, Leia, maybe you can show once again the tip that we use. So in the kit, you have a standard, the white one used for calibration, which is a special kind of tip, which really reflects all of the light. So we calibrate against that, and then we take the further samples. So it's a really small tip that you will take possibly to the field and calibrate during the day that you will be using that. Okay, and also we can have some more information from William that will join right now.
Okay, I think thank you very much. If you have any more specific question during lunchtime, you can discuss with Matthew. Now, I think we still have 2 more sessions before lunch, 3 more sessions. So I would like to invite Leah now for your session on agri-tech scan form. Yes, please.
Okay, you have it, and when you want to do, okay, yeah. As you wish. Yeah, okay.
Okay, great. Okay.
Maybe you can click around. I will be here.
Okay, perfect. Okay, hello everybody. Just want to say thank you so much for your participation and attention today. I know we're getting close to the end of the session, so I just want to go quickly to speak to you about one of our other products today, which is called ScanForm. It allows for scalable handwritten data collection for all environments. So, as I said, my background is in health, working in different health clinics, ones that are very rural, not connected to any electricity, and relying on a lot of paper to collect that information from the patients. But this is a problem, that exists everywhere. How can we collect this handwritten data at scale, especially in environments that have limited resources? For example, like I mentioned, electricity might not be accessible everywhere. Internet connection might not exist or might not be reliable. Other electronic solutions like computers are challenging to learn. They take a lot of time, a lot of people. And ultimately, there's a lot of work involved with this data. It's always double data entry, at least once on paper, maybe even more, and then later entered into a computer. So we have created ScanForm, which complements existing data systems by allowing them to intake paper. And as I'll demonstrate for you shortly, it works as easy as these 4 steps. First, you write on paper, as everybody is used to doing, everybody is trained. This can be any size, any form factor. Step 2 is you take a picture with a typical Android smartphone. I'll show you shortly. And then within seconds, you can get that data in an Excel format. And lastly, the most important step, you can use this data to analyze and to make informed decisions. All of this can be done without stable electricity, computers, or scanners. So now I'd like to show you quickly how ScanForm works. Oh, good. My screencast is full. Can you switch over? So I'm not sure if, maybe you've been sick once or twice. Maybe you've gone to a clinic before. Maybe someone in your family works as a nurse or in a facility, and they're collecting all this data all the time about people that are coming to the clinic for services. So pretending that I am a provider at a clinic and I am capturing information on all the patients that I'm seeing. And I finished a page of data and I'm ready to upload it here. So I can show this around when the presentation is done, but here's a simple little register inspired by something that you might see for HIV data. So when I open the ScanForm app, I tap it here and I can see there's some old pictures here of some data that I have uploaded, but I want to upload a new page of data. So I tap the camera and I rotate using, actually I'll put it on the back. So using the 4 green boxes, I take a picture and I can see, since I'm connected to internet right now, all uploads have finished already. And I can see this entry here at the top with today's date and timestamp. And I can see that this page of data with my handwriting has already been uploaded. So now I kind of want to show you what's happening under the hood of ScanForm, under the car. So we can see right now already that my upload has been received. If we click on the entry, here we can see all of the fields. For example, the test kit expiration date. There is my handwriting, and that's how ScanForm was able to extract that information correctly. As we scroll down, we can see all of the different fields and all of my selections have been received and accurately extracted. When we click Show Details, we can see that the ScanForm artificial intelligence was 99% certain that it extracted my handwriting correctly. And another really powerful feature about ScanForm is we can see the original image. So normally I'm based in the United States, in Pittsburgh, Pennsylvania. So right now it's 12 hours behind us. But if I'm helping a clinic here in Cambodia, I can see a picture of the data that they uploaded. They keep their data at their facility, and I can help perform a data quality assessment from thousands of miles away, remotely, just like this. And we can see what the facility collected and what data was uploaded. So now that I've demonstrated, how this picture was received, how the information was extracted, now we can actually go check out how we can use the data. So this is a simple dashboard that we developed. Right now, as you can see, there's no entries in it. We didn't have any data here before. But after refreshing, we can see that the numbers have changed. Indeed, there are 10 rows of data on this page of paper. We can see the distribution of the dates, and this is all fake data, but 3 positives were identified and 7 negatives. You can kind of scroll. If we scroll through, you can see different ways of looking at your data. Any way that you want to analyze it and visualize this information from paper, we can do that for you. So this is the power of ScanForm to gain digital data in a snap of a picture in seconds into a digital format so that you can use it quickly and accurately. So now we'll go back to the presentation. And here at QED, there's so many different systems that exist. So many of these parallel systems, maybe don't work well together. And at QED, we are not in the business of building parallel systems. ScanForm enhances existing systems. We are compatible with a variety of file formats. We use Excel. We can even use ODK style XLS forms for the specifications. We have state-of-the-art security measures as well. And, we partner with different ministries of health to be in compliance with their national data policies. So a common question that we get asked, what about data quality with ScanForm? So because of the power of taking a picture of every single page of data, we're able to perform a data quality assessment on every image upload. So this means real-time monitoring of important indicators like accuracy, completeness, missing pages, timeliness. This, like a fully digital system, all of logic violations and alerts can be caught and categorized. The result of this is that this is a massive reduction in costs through remote supervision. Like I said, I can be thousands of miles away and look at the same data that's being collected without this register ever leaving that facility. All of this data quality is compiled into a data quality report. And on the right, you can see a screenshot of the ScanForm app where all of these reports are pushed directly back to the phone. So if there's any data quality errors, the facility can receive this report, make their corrections, retake the picture, and that's it. So data quality can be improved upon in that reporting month instead of something separate later. Additionally, completeness tracking is built directly into the phone. So say, for example, I uploaded a picture of page 3 and a picture of page 5. ScanForm will send a notification, just like this image is showing, that page 4 is missing. And it reminds the facility to please upload this picture so we can make sure that we maintain completeness of our data. Another question we get asked, are these paper tools that I'm used to, are they being redesigned? The short answer is yes, but it's the same questions in layout, and we add boxes to capture letters or numbers, and we add ovals to mark selections for high accuracy. And we can make these conversions very, very quickly. So, like I said, my background is in health and different health tools, health registers, but a variety of information is being collected on paper, including agricultural data. This is an example from our partner, CIMMYT, some of the field notes, the yield trial notes that they were collecting for their wheat. Paper is used to even collect agricultural data in the field. This is another example of what those yield trial notes look like, a lot of paper and a lot of information being collected. This is the ScanForm version. So it looks very similar. As I mentioned, the only difference is that in one box, you either write one letter or one digit, and we use ovals to mark selections. Here's another example. This is for HIV viral load data, or basically when blood samples are collected from the facility and they have to be sent to the lab for analysis. This is an original form from Malawi. And this is the ScanForm version of that form. The same information is collected. Again, it's now just scannable with our application. So that way this information can be received quickly and accurately in a digital format. Many of us, we're wearing our masks right now. We're quite aware of the pandemic of COVID-19. And this is an example of the case report form from the WHO that is also made scannable with ScanForm. This means that real-time pandemic surveillance is possible with ScanForm. These forms are completed, and it takes a lot of time to manually enter, manually type this into a computer. All of that can be replaced with taking a picture. Another question we get, how accurate is ScanForm? So like I showed you under the hood, we have a whole verification interface to look at the data. And right now, the accuracy is at about 99.8%, and it continues to get smarter over time. That interface that I showed allows for humans like me or you to inspect the data and make any adjustments in case the AI was uncertain. But as you can see in the screenshot, it is very good at extracting different types of handwriting. Additionally, every country that ScanForm is deployed, we calibrate the artificial intelligence to local handwriting samples from that country. So ScanForm continues to get smarter and smarter over time. This is some example results from Malawi, where we did an independent evaluation on ScanForm's accuracy. And we found that ScanForm's AI was over 98% certain. Another question we get, frequently is, I have bad handwriting. How good, is it with my poor handwriting? You can see in this picture, the handwriting is a little difficult outside of the box. ScanForm was able to extract all this information at an over 95% certainty. Here's another example of even worse handwriting. So imagining some type of data clerk at the facility would receive this paper form, and they have to manually tabulate the summaries from this data. It's very hard with the human eye to look and see what this is. But ScanForm was able to extract everything very well. Only 8.6% of what you're seeing on this screen needed to be corrected with ScanForm. Another example that can happen, pens dying, running out of ink. That didn't stop ScanForm, and ScanForm was still able to extract everything very well. And this is one of my more favorite examples. This handwriting is quite different, very Martian-like handwriting, very slanted. But again, this was no trouble for ScanForm, so it can work very, very well in a variety of handwriting styles. Another question that we get asked all the time, what kind of security do you take with ScanForm? Since a lot of this information that is collected is PII, or personal identifying information, this is very, very sensitive information. So we're very, very careful with it. In addition to the phones, we offer a service called mobile phone hardening. It basically ensures that only ScanForm can be used on the phone. We're able to also track the location of the phone, shut down any other apps. We can even do some engraving and just try to deter any likelihood of theft. Here's another example of dewarping and redaction. Sometimes the picture can be taken at an angle, as you see in the image on the left, but ScanForm is intelligent enough to know to flatten that image. Additionally, if you look at that image on the left side of that dashed border, that's where the PII was being captured. This is just fake data, nothing sensitive here. But ScanForm automatically crops the image, as you can see in the right. Anything to the left of that dashed margin is not included in the picture. Here's a better example of the redaction that I'm talking about. So again, you see the dashed lines around the page of paper. Outside of it on the left is where the PII would be captured. Now, sometimes in the case of HIV, capturing PII is very important for the facility to make sure they can follow up with this client and make sure that they're sticking to their medicine. So the facility would need to access this information. Otherwise, nobody else needs it. So when you take the picture using the 4-corner guides, this is a screenshot of the image being processed after taking the photo. And again, everything within that red dashed line is what ScanForm captures. Everything else is cropped. This is what the real image looks like. You can't see that PII in the left-hand margin. So again, that information is only meant to be used by the facility, but from a data aggregation standpoint, it's never stored in the image, nor is it uploaded to ScanForm. So yes, as I mentioned, it's never on the phone, never uploaded. So quickly, a little bit about our impact. Since 2018, more than 20 million patient records have been processed with ScanForm. In the top right corner, you can see the flags of the countries where ScanForm has been used, as well as the logos of our various partners. We have a lot of experience converting many routine tools already converted into ScanForm, outpatient department registers, HIV testing services, antenatal care, and many, many more. This isn't a complete list. But, like I said, my background is in health. ScanForm is very versatile. In this top screenshot, you'll see that this is an attendance form actually being used in Nigeria right now to capture school attendance data, since all of that information is collected on paper. And now that is digitized rapidly with ScanForm. In the bottom screenshot, you can see this is a legal intake form. So lawyers actually used a scannable form to create cases for refugees that were coming into the United States from Mexico. What I'm trying to say is any information that's collectible on paper is suitable for ScanForm, including agricultural data as well. So this is just a couple example success stories. Right now in Malawi, ScanForm is scaling up nationally to nearly 800 facilities. All HIV testing services data will be captured with ScanForm. It's also been used for malaria surveillance, and 20,000 community health volunteers in Kenya are also using ScanForm for surveillance. Here's just some pictures of the volunteers in the community using ScanForm. Because it's so simple and scalable, ScanForm is great for any community use. This is an example of how the workflow can work, for example, collecting COVID-19 data. On the left, you see the ScanForm approach. First, write on a ScanForm register, you take a picture, and you get accurate, near real-time dashboards. Compared to the traditional approach on the right, where you're writing on paper, somebody again has to manually summarize that into a weekly summary, perhaps again for a monthly summary. Somebody has to enter that into a computer to get it into a national database. That can be very time-consuming and create a lot of backlogs. This is a real example of a cost benefit from one particular country pertaining to COVID-19. Basically, the green bar shows the cost to print the ScanForm registers, compared to the red bar, which is the cost to print the traditional registers, as well as the cost of the data clerks doing all of that manual transcription that I was describing. So in this example, ScanForm can save about $500,000 just for this one country alone. Recently, we also were selected as a winner of the Bill and Melinda Gates Foundation and MIT Solve competition. About the prompt was, how might we use unconventional methods to measure the improvement of primary healthcare performance in low and middle income country? And I'm pleased to share that ScanForm was selected as one of the winners out of over 300 international solutions. So just want to wrap up quickly before I open it up to questions. In conclusion, ScanForm saves money because costs of transcription are minimized. By doing fully automatic data quality assessments, costs associated with monitoring and evaluation are substantially reduced. And then additionally, the ScanForm app also contains various training materials and videos. So this can allow for free trainings, which can also be a very expensive cost for different ministries with per diems and lodging and things like that. Now you can just do it directly from your phone. ScanForm also improves data quality as well as timely access for different ministries, including ministries of agriculture. And it's less burden on field enumerators. Writing on paper is something everybody is very familiar with, and it's very easy, requires less training, and it's very simple and scalable. So I want to open this question up before we conclude with today's session, but as I said, any Cambodian data that's collected on paper could be suitable for ScanForm. So the question that I'd like to pose to you all is, how can we strengthen Cambodian data systems by working together? Because we believe with ScanForm and electronic solutions, we can have a complete picture of the agricultural sector or the health sector, whatever sector of data that we're collecting, it can be complete together with ScanForm. Thank you.
Okay. យើងមើលទៅដូចជាពេលវេលាយើងខាយណាឥឡូវមានសំណួរប្រហែលឃើញមានមួយមានណាទៀតទេបើសិនជាមានល្មមអីយើងអាចសួរគាត់ផ្ទាល់ណាឥឡូវយើងប្រគល់ជូនគាត់មួយបាទសូមអរគុណ
Hi. This ScanForm looks very exciting. It is going to have a lot of practical applications from the point of monitoring and evaluation and MIS. Looks very interesting to me. Firstly, I want to know, downloading the data into Excel, is it easy? Because for further analysis.
Very easy. It's just a click of a link. Yes.
Super. And then what is the cost of this software?
That's a great question. So the cost is, it's very, very, what it ends up, ScanForm ends up costing orders of magnitude less than other solutions because of how it eliminates other expensive things like the manual data entry. That's a challenging question to answer because it depends on the data throughput, the amount of data coming in each month. but I can assure you, maybe with a little bit more information, it's quite affordable. We partner with a lot of ministries. We want this to be a sustainable solution for ministries to adopt and continue to sustain. So it's quite affordable is my best answer.
For example, see, we have people here, right?
Yeah.
If they want to evaluate this training program using the scan form, approximately how much it will cost?
Cheap.
Uh-huh.
Cheap.
Because
that would just be maybe 50 data points or so, one from each person. Perhaps the evaluation form would be a single page. It would be like I don't even know how to say it. It would be so cheap.
Okay, so because I find this very interesting, this scan form, it's going to have a lot of practical applications from the point of M&E planning MIS. My last question is, if, for example, people make a lot of errors in, for example, if they want to give an answer like excellent, and then they change it to good, if they make this kind of errors, will it affect the accuracy?
So no problem with the errors. If an error has been made, like I was showing, it's different boxes and ovals, right? So if there's an error in a box, you just shade the box completely and write the correct answer beneath it, retake the picture, you're finished. No problem. If you've marked, with the ovals, we use that to mark a selection. For example, male or female. If you accidentally mark male, you shade the oval completely and mark female. Retake the picture. That's how you make your corrections. So ScanForm can handle it, no problem.
Thank you very much.
Thank you.
Thank you.
Thank you.
I would like to invite you.
Thank you. Yeah.
Okay, so the last part we have dedicated so that we just can have open discussion about the possible solutions to implement, the possible ideas that we can cooperate together with. So it can be open-ended. We can just walk around and maybe chat through what are the possible applications. So maybe we can just have some more questions if you have any. We can also have questions from the ScanForm side if you wish. And if there are no exact questions, maybe you can just spend some time here and be available for you to talk to. So maybe you can start with if there are any other questions that you wanted to address.
Okay, have about 10 minutes.
Yes, yes.
Okay. Anything? Okay, if you want to say something more, if you want to say something more, please. We have about 5 more minutes.
Okay.
If no more questions.
Okay, okay. Yes, so we'll be around here, and if you need to, you can just come over to us and we can chat more. We will be around here in the venue. So yeah, thank you.
Okay, well, we're nearly done with today's session. I just want to reiterate my gratitude for the opportunity for us to speak to you today. It has been a wonderful experience. This is both of our first time in Cambodia, so we are just greatly appreciative to have your attention and audience. I hope that you found our presentations interesting. Maybe perhaps some ideas about using scan spectrum in the field or using scan form in the field. We would love to talk with you more about your ideas on how to use our tools, because as we said, from QED, we are here to empower ministries and empower organizations with their systems and their processes. So please, we have business cards. We would love to talk more with you, with your ideas. But again, thank you so much. We really appreciate it.
So now we are reaching the now we are reaching the closing. Okay. Before I giving my findings, also some reflections or way forward, I would like to invite Dr. Upich so that he can share of his views and from his colleagues. So what he finds the training today or these applications or information. So please, it's your floor now.
But ជាបឋមសូមគ្រប់អាដាមសិទ្ធិភ័ក្រជាគ្រប់គ្រងកម្មវិធីនៃការប្រតិកម្មចែងកទីគ្រប់ជំរុបបងហែមចន្ទធូមន្ត្រីជាន់ខ្ពស់នៃធនាគារអវត្តអាស៊ីបាទថ្ងៃនេះខ្ញុំមាននឹងសូមគ្រប់នាងធនាគារអវត្តអាស៊ីបាទនឹងលោកលោកស្រីទាំងអស់ដែលមកពីក្រសួងកសិកម្មក្រសួងដែនដីនគររូបនីយកម្មនិងបណ្ដាហេតុគោលដៅនៃគម្រោងទាំង3បាទថ្ងៃនេះខ្ញុំមានកិត្តិយសរីករាយដែលបានចូលរួមក្នុងកម្មវិធីបិទវគ្គបណ្ដុះបណ្ដាលស្ដីពីការប្រើប្រាស់ទិន្នន័យនិងកម្មវិធីបញ្ញាសិប្បនិម្មិតបាទដែលសូម្បីខ្ញុំក៏ថ្មីដែរមិនបាទជាវគ្គបណ្ដុះបណ្ដាលមួយដែលខ្ញុំគិតថាជាថ្មីសម្រាប់ការចោះប្រមូលទិន្នន័យនិងការវិភាគនេះតាមប្រព័ន្ធ satellite តែយើងខ្ញុំជឿថាជាពិសេសមន្ត្រីមកពីក្រសួងកសិកម្មនិងមន្ត្រីមកពីអគ្គនាយកដ្ឋានកសិកម្មនៃក្រសួងកសិកម្មនេះនិងក្រសួងដែនដីនគររូបនីយកម្មបាទហើយសូមថ្លែងអំណរគុណផងដែរចំពោះការគ្រប់គ្រងថវិកាពី ADB និងការរៀបចំរបស់ខាង EA ខាង PMO យើងហៅកាត់គម្រោងដែលបានបង្កើតវគ្គដំណើរនេះឡើងដែលធ្វើឲ្យពង្រឹងសមត្ថភាពពាក់ព័ន្ធនឹងការចោះស្ទង់ទិន្នន័យនិងការប្រមូលទិន្នន័យយ៉ាងនេះតាមរយៈប្រព័ន្ធ satellite ខ្ញុំជឿថានេះជាជំហានដំបូងទេជាចំណុចចាប់ផ្ដើមសម្រាប់អគ្គយុវដ្ឋានកសិកម្មយើងនេះហើយយើងសំណូមពរដែរថាប្រសិនបើមានវគ្គដំណើរនេះទៀតយើងឃើញថាការរៀបចំនឹងអាចបញ្ជ្រាបដល់ទៅតាមមន្ទីរកសិកម្មខាងនេសាទខេត្តបន្ថែមទៀតកាន់តែប្រសើរព្រោះតាមខ្ញុំទទួលបានព័ត៌មានមួយចំនួនពីមន្ត្រីរបស់ខ្ញុំបាទពីសហការីរបស់ខ្ញុំបាទនិយាយថាវគ្គនេះគឺឃើញថាមានការខ្ពស់បន្តិចពិបាកនឹងការទទួលយកខ្ញុំថាសំណូមពរខាង ADB ផងដែរនិងបើសិនជាមានវគ្គដំណើរអាចថានឹងជួយពង្រឹងបន្ថែមបន្តទៀតដើម្បីយើងដូចយ៉ាងណាអាចបន្ស៊ាំនៅបច្ចេកទេសថ្មីនេះដើម្បីប្រើប្រាស់មានប្រយោជន៍សម្រាប់ការងារវិភាគប្រមូលទិន្នន័យពេលអនាគតរបស់យើងបាទហើយខ្ញុំក៏ជារួមនៅក្នុងការលិខិតអញ្ជើញរបស់ខាងម៉ានអូរបស់យើងគឺយើងបញ្ជាក់ដែរថារកអ្នកចេះខាងកុំព្យូទ័រយើងថាពិតប៉ុន្តែយើងដើម្បីថាយើងធ្វើម៉េចពោះការងារប្រើប្រាស់កុំព្យូទ័រច្រើនហើយក្នុងនោះជាមហិច្ឆតារបស់ខ្ញុំបាទដែរថាយើងសូមរហូតទៅដល់30នាក់ជាងនិយាយថា34នាក់35នាក់ដើម្បីចូលរួមនោះដើម្បីថាព្រោះអីព្រោះដំណាំយុគឋានដំណាំទាំង3ជានឹងយុគឋានគ្រប់គ្រងធនធានកសិកម្មនេះក្នុងនោះយើងមានផ្នែកខាងផែនការស្ថិតិមួយទៀតពួកគាត់ត្រូវការប្រមូលទិន្នន័យជាប្រចាំបាទពាក់ព័ន្ធដំណាំនេះបានន័យថាយុគឋានទាំងហើយនឹងយុគឋានទូចំណាំមួយទៀតដែលគាត់ចុះក្នុងការគ្រប់គ្រងន័យថាជាយុគឋានស្នូលមួយក្នុងការប្រមូលទិន្នន័យចាំបាច់ជាពិសេសយុគឋានគ្រប់គ្រងទិន្នន័យកសិកម្មនេះតែម្ដងបាទតែគាត់ត្រូវការធ្វើក្របសូនីងគាត់ត្រូវការធ្វើផែនទីគ្រប់គ្រងដីកសិកម្មនៅទូទាំងប្រទេសកម្ពុជានេះហើយបច្ចុប្បន្ននេះក៏អាដាមរដ្ឋមន្ត្រីលោកក៏ជំរុញឲ្យការរៀបចំជាក្របសូនីងចាំបាច់នៅតាមបណ្ដាខេត្តជាងផងដែរបាទសាយថ្មីសូមគោរពថ្លែងអំណរគុណបងគម្រោង ADB និងអង្គភាព PMO រួមនឹងដំណើរដែលបានចូលរួមនិងគ្រប់គ្រងក្នុងវគ្គដំណើរនេះបាទហើយសូមគោរពជូនពរអាយដាមលោកស្រីទាំងអស់នៅពរទាំង4ប្រការយុវណៈសុខៈលក្ខ3គ្លៀងឡើយបាទហើយនឹងសូមទទូចផងដែរថាសូមឲ្យមានការបន្តវគ្គដំណើរបន្ថែមសូមអរគុណ
អូខេបាទខ្ញុំបាទចន្ទធូហែមចន្ទធូខ្ញុំជាមន្ត្រីរបស់ធនាគារអាវ៉ាស៊ីហើយនឹងជាប្រធានការងារពីខាង ADB ធ្វើការសហការជាមួយអេដាមសុភ័ក្រហើយខ្ញុំក៏និយាយចំទៅខ្ញុំជានិស្សិតមួយជាមួយបងប្អូនទាំងអស់គ្នាដែរណាជា trainee មួយដែរហើយក៏ឆ្លៀតពេលហ្នឹងក៏ជួយសម្របសម្រួលការងារបន្ថែមហើយខ្ញុំសូមធ្វើចំណាប់អារម្មណ៍ខ្ពស់សូមឃើញថាវាគ្មិនទាំង4ទាំង5ទាំងមីស៊ីកូគឺមានសមត្ថភាពពេញលេញហើយមានចិត្តចង់ចូលរួមជួយលើកកម្ពស់សមត្ថភាពជួយស្វែងរកបច្ចេកវិទ្យាថ្មីដើម្បីឲ្យប្រទេសកម្ពុជាយើងបានទទួលហើយប្រសិនបើខ្ញុំគិតមើលជាបទពិសោធន៍ជារួមក្នុងការចូលរួមធ្វើការងារអភិវឌ្ឍប្រទេសកម្ពុជាជាង20ឆ្នាំមកនេះយើងឃើញថាគម្រោង Rice SDP ដែលអាយដាមសុភ័ក្រគាត់បានគ្រប់គ្រងចាត់ចែងកន្លងមកនេះឃើញថាមានភាពច្នៃប្រឌិតមានភាពស្វែងរកគំនិតថ្មីជាច្រើនយើងមានតាំងពីការធ្វើគៀពង្រៀបដីការគៀពង្រៀបដីយើងមើលទៅថាសាមញ្ញប៉ុន្តែអ្វីដែលគាត់បានធ្វើមិនមែនត្រឹមតែពង្រៀបដីទេគាត់បានបង្កើតជំនាញចំណេះទីផ្សារដែលបន្ទាប់ពីយើងធ្វើការងារមិនតាន់ទាំងចប់ផងគឺវិស័យឯកជនអាច ធ្វើការងារនឹងបានដល់ខ្លួនឯងលើសពីអ្វីដែលយើងបានជួយចូលរួមសម្រាប់កម្ពុជាទៀតអញ្ចឹងអ្វីដែលយើងធ្វើគ្រប់បែបយ៉ាងទាំងអស់សិតតែមានលទ្ធផលធំជាងអ្វីដែលយើងបានរំពឹងទុកសូម្បីតែជួយទៅលើការសម្ងួតជួយទៅលើ processing ផ្សេងហ្នឹងយើងគាត់ដាក់ទៅទេគឺការងារហ្នឹងវាមានការធ្វើបានល្អរដ្ឋាភិបាលនឹងបានលុយវិញអត់មានបាត់បង់ជួយសងទៅធនាគារវិញហើយការងារជាមួយវិស័យឯកជនដើរហើយឯកជននឹងធ្វើការដោយផ្ទាល់ជាមួយនឹងកសិករបានផលល្អហើយកសិករបានទទួលផលអញ្ចឹងយើងមើលទៅការដែលធនាគារវ៉ាស៊ីបានជួយទៅលើកម្មវិធីនេះគឺមានឥទ្ធិពលខ្ពស់គឺលុយអត់មានការបាត់បង់ក្រៅពីនោះគឺបានបង្កើតអ្វីដែលមានដល់សល់ហើយជាមួយគ្នានេះជាមួយកម្មវិធីអ្វីដែលយើងបានធ្វើនេះឧទាហរណ៍យើងខ្ញុំក៏អត់ដែលបានធ្លាប់គិតថាយើងអាចធ្វើអញ្ចឹងបានដែរយើងមាន thinking machine យើងមាន QED ហើយពេលដែលយើងកំពុងតែ lockdown យើង restriction ហើយមិនដឹងណាទៅធ្វើការនរណានៃអីផ្សេងប៉ុន្តែមីស៊ីកូក៏គាត់បានជួយសម្របសម្រួលការងារនេះមកដល់ពេលនេះគឺយើងមានអ្នកចុះតិចតួចចុះសម្ភារចុះអីផ្សេងទៅហើយយក GPS ឲ្យធ្វើប្រហែល390គ្រួសារហើយជាមួយព័ត៌មានដែលមាននៅលើអាកាសជាមួយនឹងផែនទីដែលគេថតទុកកន្លងមកជាមួយនឹងភាពឆ្លាតវៃដែលកុំព្យូទ័រអាចបង្កើតគេអាចបង្កើតទៅជាផែនទីបង្កើតទៅជាការវិតម្លៃមួយដែលមានភាពសុក្រិតដែលយើងអាចទទួលយកបានហើយយើងកិច្ចការងារនេះអ្វីដែលយើងបានបង្ហាញនេះថ្ងៃនេះដូចជា scan form ឲ្យខាងអ្វីដែល Rice SDP ប្រហែលជាយកទៅធ្វើឲ្យមុនគេតែទៅលើផ្នែកខាង M&E ហើយយើងប្រហែលជាអាចប្រើប្រាស់បានភ្លាមហើយមួយទៀតប្រទេសកម្ពុជារបស់យើងតាមរយៈក្រសួងកសិកម្មយើងបានធ្វើការងារច្រើនហើយការងារហ្នឹងវាធ្វើហើយវាបានរយៈពេលខ្លីហើយវាកប់ទៅបាត់ធ្វើបានរយៈពេលខ្លីក៏ឧទាហរណ៍ដូចយើង agro ecological analysis យើងធ្វើ smallholder ក៏ធ្វើ Rice SDP ក៏ធ្វើហើយយើងធ្វើរហូតដល់ផែនការដីធ្លីហើយឥឡូវនេះយើងចេញពីអ្វីដែល traditional យើងធ្វើកន្លងមកយើងបានធ្វើឲ្យទៅជាមានកន្លែងតាមស្តុកព័ត៌មានអាចចែករំលែកព័ត៌មានហើយអ្វីដែលយើងបានរៀននៅថ្ងៃនេះប្រសិនបើក្រសួងកសិកម្មហើយអ្វីដែលក្រសួងកសិកម្មកំពុងធ្វើប្រសិនជាប្រឹងថែមបន្តិចទៀតយើងមានស្អីspectrum យើងមានស្អីយើងរៀនហ្នឹងប្រសិនបើយើងអាចបញ្ចូលព័ត៌មានទាំងអស់ហ្នឹងដីនៅកន្លែងនេះមានគុណភាពនេះវាអាចត្រូវស្អីណាហើយវាអាចស្អីអញ្ចឹងអាចធ្វើឲ្យក្រសួងកសិកម្មក្តីក្រសួងផែនការក្តីអាចធ្វើផែនការសម្រាប់ប្រទេសជាតិខាងមុខតំបន់ណាត្រូវដាំស្អីតំបន់ណាត្រូវធ្វើស្អីតំបន់ណាត្រូវធ្វើអីផ្សេងទៀតហើយអ្វីដែលយើងព័ត៌មានបានពី field មានអ្នកដែលនៅថ្នាក់ជាតិអាចតាមដានមើលជាប្រចាំសង្ស័យអីអាចប្រាប់ទៅថ្នាក់ស្រុកថ្នាក់ឃុំមើលជួយទៅមើលកន្លែងទៅនេះមើលវាយ៉ាងម៉េចហើយព័ត៌មានចេញពីនឹងមកយើងអាចវាតម្លៃបានណាអានេះវាជាស្ថានភាពជំងឺអានេះវាជាស្ថានភាពយ៉ាងម៉េចហើយកម្ពស់ទឹកប៉ុណ្ណឹងកម្រិតទឹកប៉ុណ្ណឹងផលនឹងវាអាចបានយ៉ាងម៉េចហើយតើគួរអន្តរាគមន៍យ៉ាងម៉េចខ្ញុំជឿថាកិច្ចការងារនេះគឺផ្ដល់ផលបានច្រើនហើយខ្ញុំសង្ឃឹមថាបងប្អូនទាំងអស់គ្នាក្តីហើយខ្ញុំក៏ខំប្រឹងប្រែងបន្ថែមដែរហើយយើងនឹងប្រមូលយកអ្វីដែលយើងបានរៀនថ្ងៃនេះប្រហែល2ថ្ងៃ3ថ្ងៃកន្លងមកនេះហើយជាមួយនឹងព័ត៌មានទៅពេលខាងមុខទៀតយើងគិតច្នៃប្រឌិតឲ្យបានច្រើនជាងនេះទៀតដើម្បីធ្វើគម្រោងថ្មីយើងទៅ generate ព័ត៌មានអីខ្លះស្ថានភាពបច្ចុប្បន្ននឹងយ៉ាងម៉េចហើយនៅពេលខាងមុខ3ឆ្នាំទៀតយើងទៅវាតម្លៃវាយ៉ាងម៉េចហើយពេលចប់យើងគិតធ្វើយ៉ាងម៉េចហើយខ្ញុំជឿថាយើងនឹងបានទទួលផលច្រើនជាងយើងធ្វើដោយយើងធ្វើព្រាវបាទអញ្ចឹងសូមអរគុណច្រើនខ្ញុំសូមជួបរួមត្រឹមនឹងបាទអរគុណច្រើនបាទសូមប្រគល់ជូនឯកឧត្តមសៀកសុភ័ក្របាទហ្មងណាបាទ
បាទជាបឋមសូមគោរពលោកស្រីមីជីកូបាទលោកហែមចន្ទធូលោកអបពេជ្រហើយនិងអាដាមលោកស្រីទាំងអស់បាទខ្ញុំសូមសម្ដែងនៅការអបអរសាទរចំពោះសកម្មទាំងអស់ដូចជាខាង trainer មកពីខាង thinking machine ហើយនិង ADB ដែលបានយើងបានបញ្ចប់វគ្គសិក្សា2ថ្ងៃកន្លះនេះដោយជោគជ័យបាទហើយតាមព័ត៌មានដែលខ្ញុំផ្ដល់មកជាពិសេសបន្ទាប់ពីមានអ្នកបកប្រែមកគឺសកម្មការពិសាកាន់តែរស់រវើកជាងមុនបាទអញ្ចឹងគោលបំណងនៃសិក្ខាសាលារបស់យើងនឹងគឺយើងចង់បញ្ជ្រាបការយល់ដឹងអំពីការប្រើប្រាស់ទិន្នន័យផ្កាយរណបនិងការវិភាគទិន្នន័យដោយប្រើ AI ដើម្បីបញ្ចេញជាលទ្ធផលសម្រាប់យើងមកប្រើក្នុងវិស័យកសិកម្មឬក៏វិស័យផ្សេងទៀតដែលយើងអាចប្រើបានបាទអញ្ចឹងខ្ញុំសង្ឃឹមថាសកម្មយើងទោះបីមិនចេះក៏អាចដឹងខ្លះដែរអញ្ចឹងខ្ញុំសូមឈាតសួរបន្តិចសូមផ្សាយឲ្យត្រង់អ្នកណាដែលដឹងថាឥឡូវគេប្រើប្រាស់យ៉ាងម៉េចអាហ្នឹងថាយើងរៀន2ថ្ងៃកន្លះហ្នឹងថាទិន្នន័យហ្នឹងយើងនិយាយពីស្អីមិនចាំបាច់ថាចេះទាញយកមកវិភាគទេព្រោះដឹងថាហ្នឹងយល់ពីហ្នឹងគ្រប់គ្នានៅបាទស្កាត់ជ្រាបតែសង្ឃឹមថាយល់ហើយព្រោះគាត់តែយល់គឺយល់ថាហ្នឹងគឺអាចធ្វើអីបានបាទសុំលើកដៃមួយដែលថាយល់ថាអានេះសិក្សា2ថ្ងៃកន្លះអំពីស្អីបាទសុំកុំអៀនណាបាទអញ្ចឹង
បាទសូមអរគុណដល់អាយដាមបាទកាត់ទៅដោយសារពួកដោយសារខាងយើងខ្ញុំធ្លាប់បានចូលរួមវគ្គបណ្ដុះបណ្ដាលតាក់ទងជាមួយនឹង big data តែពេលអញ្ចឹងវាតំណែងហ្នឹងវាដល់ពេលជាមួយនឹងការបត់បង្ហាញរបស់វាគ្មិនថ្ងៃទី1ហើយនិងថ្ងៃទី2ហ្នឹងគឺវាប្រតិបត្តិជាមួយនឹងអ្វីដែលខាងស្ថាប័នរបស់យើងខ្ញុំត្រូវធ្វើថាតើក្រៅពីទិន្នន័យដែលយើងទៅធ្វើផ្ទាល់តើយើងអាចធ្វើអ្វីបានផ្សេងទៀតពីទិន្នន័យដែលមាននៅលើអនឡាញដើម្បីយកមកប្រៀបធៀបជាមួយនឹងទិន្នន័យដែលមានជាក់ស្ដែងតើយើងត្រូវធ្វើយ៉ាងម៉េចព្រោះយើងសង្កេតឃើញថាក្រោយពី COVID-19 នេះគឺទិន្នន័យ digital បានដើរតួនាទីយ៉ាងសំខាន់នៅក្នុងការទាញយកនៅទាញយកនៅតួលេខដើម្បីយើងអាចយកមកវិភាគសម្រាប់រៀបចំផែនការគោលនយោបាយទៅមុខទៀតហ្នឹងតើយើងត្រូវក្រៅពីអ្វីដែលយើងមិនអាចធ្វើបានជាមួយនឹងការទាញយកទិន្នន័យដោយផ្ទាល់បានហ្នឹងតើទិន្នន័យ digital អាចចូលរួមចំណែកជួយអ្វីខ្លះបានតទៅទៀតហើយវាពិតជាមានសារៈសំខាន់មែនទែនបាទជាមួយនឹង machine learning ហ្នឹងគឺជាផ្នែកមួយនៃ big data ដែរបាទអរគុណ
បាទសូមអរគុណអញ្ចឹងហើយជាមានសកម្មភាពខ្លះអាចនឹងប្រើប្រាស់ទាញវិភាគទិន្នន័យតែម្ដងសកម្មខ្លះអាចបាទយល់ប៉ុណ្ណឹងក៏គ្រប់គ្រាន់ដែរព្រោះចង់ឲ្យយល់ថាហ្នឹងជាស្អីបាទដូចបងខាងស៊ុំផែនការអាចដឹងរឿងពីមុនច្រើនក៏ដឹងដែរបាទអញ្ចឹងខ្ញុំសង្ឃឹមថារយៈពេល2ថ្ងៃកន្លះនេះសិក្ខាកាមទាំងអស់ទី1ស្វែងយល់អំពីសារៈសំខាន់នៃការប្រមូលទិន្នន័យហើយនិងការគ្រប់គ្រងទិន្នន័យបាទទី2គឺពួកគ្នារវាងការប្រើប្រាស់បច្ចេកវិទ្យានេះជាមួយនឹងការទៅប្រមូលទិន្នន័យនៅលើដីផ្ទាល់តែម្ដងដឹងថាខុសគ្នាយ៉ាងម៉េចហើយបាទអញ្ចឹងទី3គឺគុណសម្បត្តិនិងគុណវិបត្តិនៃការប្រើប្រាស់បច្ចេកវិទ្យា AI នេះបាទហើយទី4គឺការលំបាកនៅក្នុងការទាញយកទិន្នន័យពីផ្កាយរណបមានការលំបាកយ៉ាងម៉េចព្រោះគិតថាខាង trainer គាត់ច្បាស់ជាបានបញ្យល់ហើយបាទអញ្ចឹងទី5គឺតើយើងទៅទាញយកទិន្នន័យពីសិទ្ធិតម្លៃពីផ្កាយរណបយ៉ាងម៉េចហើយយើងអាចរក្សាទិន្នន័យនៅទៅណាបាទហើយនឹងបកប្រែទិន្នន័យនឹងយ៉ាងម៉េចវិភាគទិន្នន័យនឹងយ៉ាងម៉េចបាទការកម្មខ្លះអាច ធ្វើបានហើយអ្នកខ្លះតែធ្លាប់គាត់ជំនាញ GIS ហើយជាគាត់ច្បាស់ហើយបើថាពួកខ្ញុំគិតដឹងថាមានអ្នកខ្លះមកពីគម្រោង SDP ខ្ញុំស្គាល់គាត់មានចំណេះកុំព្យូទ័រខ្លះប៉ុន្តែគាត់មិនប្រកាសថាគាត់ធ្វើបានក៏គាត់យល់បាទអញ្ចឹងទី6ដែលសំខាន់ដែរគឺការប្រើប្រាស់លទ្ធផលនៃការវិភាគនេះដើម្បីគ្រប់គ្រងដល់ការអនុវត្តគម្រោងបាទនោះជាចំណុចសំខាន់ហ្មងបើយើងគាត់តែចេះហើយយើងអត់យកទៅអនុវត្តគម្រោងទៀតគឺអត់មានប្រយោជន៍អីទេបាទអញ្ចឹងខ្ញុំគិតថាការដកដៅ2ថ្ងៃកន្លះរបស់យើងនេះគឺពាក់ព័ន្ធច្រើនជាមួយទាំងខាងកសិកម្មជាមួយខាងក្រសួងដែនដីទាំងខាងបងជាមួយខាងភូមិផែនការអញ្ចឹងណាបាទគឺខ្ញុំជាអ្នកប្រាប់សហការីថាឲ្យអញ្ជើញខាងផែនការផងដោយសារគាត់ធ្វើការនឹងច្រើនបាទទៅពេលអញ្ចឹងទៅពេលអញ្ជើញមកមិនមែនមានផែនការគាត់ធ្វើការនឹងច្រើនដែរបាទអញ្ចឹងបើខាងកសិកម្មរឿង CAEA ហ្នឹងតែអាចប្រើប្រាស់ទិន្នន័យពីកែណោទៅជួយវិភាគបាននៅគាត់ខ្ញុំមិនអ្នកបច្ចេកទេសទេបងអពេជ្រអាចជួយបកស្រាយបាទហើយខាងដែនដីក៏យើងមានក្លឹបដែរក្លឹបហ្នឹងក៏អាចប្រើទិន្នន័យហ្នឹងយកទៅជួយការងារក្លឹបផងយើងដែរអញ្ចឹងការរៀនសូត្រពីថ្ងៃកន្លះរបស់យើងខ្ញុំគិតថាมันវាខ្លីมันអាចថាគ្រប់គ្រាន់ទេអញ្ចឹងបើមានដំណើរការចាំបាច់បន្ថែមទៀតក្នុងនាមគម្រោងក៏ដោយគ្រប់ខណ្ឌគម្រោងហ្នឹងឬក៏តែគ្រប់ខណ្ឌគម្រោងគឺខ្ញុំលើកទឹកចិត្តឲ្យខាងក្រសួងសហប័ណ្ណស្នើមកជាទៅស្នើសហដំណរបស់ខ្លួនស្មើមួយ ADB បើមិនជាមានដំណើរការប្រកបបន្ថែមតែបើក្នុងគ្រប់ខណ្ឌគម្រោងនេះនៅពេលគម្រោងនេះនៅមិនទាន់បិទអាចបើថាមានដំណើរការផ្សេងអាចពិភាក្សាគ្នាថាទៅមានមកបន្ថែមទៀតអញ្ចឹងណាបាទអញ្ចឹងចង់បញ្ចប់តាមនាមឲ្យក្រសួងសេដ្ឋកិច្ចនិងធុតាមនាមឲ្យ PMO ហើយនឹងខ្លួនខ្ញុំផ្ទាល់ខ្ញុំសូមសម្ដែងការអរគុណលោកស្រីមីជីកូបាទលោកហែមចន្ទធូបាទខាងអ្នកប្រដបដាលមកពី Thinking Machine ហើយនឹង QED ហើយសិក្ខាកាមទាំងអស់បាទតែបានចូលរួមចូលវគ្គប្រដបដាលនេះនិងសូមអរគុណ ADB ដែរដែលបានតែគ្រប់គ្រងដល់កម្ពុជាកន្លងមកបាទហើយសង្ឃឹមថាការបន្តនេះនឹងបន្តការគ្រប់គ្រងនឹងបន្តថែមទៀតបាទហើយកាន់តែច្រើនជាងមុនទៀតបាទសូមអរគុណបាទ
វិញសិនទៅគេខតមួយបាត់ហើយ
បាទលើកទៅអញ្ចឹងខ្ញុំសូមប្រកាសបិទតែម្ដងបាទសូមអរគុណ
Just before you go, just to announce that is my colleague, Leah, another Leah from Philippines, from ADB, will send you all this email with the links to your evaluation forms. Please go there and it's fill in your opinions about how you see this training, whether or not you want to see something like this in the future, or if you have an alternative suggestion, we're all ears to your opinions. And then with the completion of the feedback, we would issue the certificate of the training completion and send it back to you. So it's a barter trade. So please pay attention to this. Thank you so much for your great participation. Thank you so much.